gases have us falling down forever into your head. September comes and goes away. Memories of celebration. So what has become of us? All the promises you made, second guesses have us falling forever into your head. September comes and goes away. Memories of celebration. So what has become of us?
Welcome to the GATE Big Data and AI Forum. My name is Silvia Ilieva and I'm the director of GATE and the moderator of today's event. The Big Data for Smart Society, GATE, is the first dedicated to big data and artificial intelligence center of excellence in Eastern Europe. Established as joint initiative with Chalmers University of Technology, Chalmers Industritechnik Sweden, it was institutionalized in 2019 as a purpose-built research institute of Sofia University. But GATE is much more. GATE is a cause and it's a result of 3 years hard work, which was acknowledged and funded both by Horizon 2020 program and operational program Science and Education for Smart Growth to boost the big data and artificial intelligence research in Bulgaria. Also, GATE is a unique thriving environment which creates a new research culture and brings and grows the new generation of research scientists. GATE is a catalyst of AI and big data endeavors at national level, bringing together science, business, and government. And also GATE is an integrator that paved the way towards successful collaboration within European research area and also with well-known initiatives like Big Data Value Association, International Data Space Association, and Open Geospatial Consortium. So today we are happy to have you with us to share in order to share with you what we achieved during this first year, and also to present views of and exchange ideas with one of the most brightest scientists and practitioners in the field, and to jointly continue to explore big data and artificial intelligence opportunities. So we're bringing together different stakeholders from science, government, industry in big data and artificial intelligence to tackle emerging challenges in the field, in the application fields of GATE, which are future city, digital health, and intelligent government. So we will have today intense program, a lovely opening with welcome notes from high-level officials. Then we'll have 4 panels with inspiring keynote speakers, and also discussions with GATE partners and supporters. And between the panels, we will learn about partnering European Big Data Center of Excellencies and innovative startups. So to set up the scene and we have here with us Mr. Peter Drow from European Commission. He was cabinet member of Enlargement Commissioner Günther Feyhofen and head of cabinet of Science and Research Commissioner Potočnik. And since 2010, he's at Directorate Research and Innovation, and currently he's Director of Prosperity in this directorate. So welcome, Peter. The floor is yours. Peter, do you hear us? Peter, are you muted or? We test the connection, but мютнете. Може ли да мютнем Карина Ангелиева и да пуснем Питър? Hello, Peter. Would you please unmute and switch on your camera with you online? Go to the next or we have also with us Karina Ангелиева, who is the Deputy Minister of Science and Education. Karina, do you hear us? Yeah. Good morning. Please, the floor is yours for welcome notes to our event.
Thank you very much, Sylvia. Good morning to everyone. Unfortunately, I don't see anyone. And unfortunately, after the great opening last year in Sofia University, this year we can't be together, which is on one point of view a little bit disappointing, because I'm looking forward, of course, to see. I see here on the list that Peter Drow is also with us. I used to work a lot with him, but also the great team of Sylvia, and I see many other people I don't know, but I'm sure that these are one of the leading partners of the Institute GATE. Thanks very much to Professor Ilieva first for this invitation, but also for her motivation and energy during this year, strange year, of a lot of challenges. Basically, she didn't give up. On the contrary, she basically proved that with a lot of work, a great team, and international cooperation, we can take the lead in this important sector of big data and artificial intelligence. It's a field where we, the politicians, very often underestimate what exactly is happening and what is the role of science. because it's so modern, this topic, very often we just think that it's happening and it doesn't need funding. But in fact, this is one of the biggest challenges in Europe now, that we need to build a critical mass. And we should build critical mass not only in leading innovating countries, but everywhere in Europe. We need inclusiveness in Europe, and we need to link the center of Europe with the periphery, because there is a lot of potential everywhere. And especially for me, one of the big opportunities after this crisis, if we want, of course, to boost the competitiveness in Europe, is really to explore the data. I'm talking a lot about this, and I think very often I'm irritating my counterparts here in Bulgaria, because it's very difficult to go out of the topic of infrastructure and to talk about the necessity to create regulations, to create tools, but also to fund universities, research centers, to invest in skills, to invest in people that are prepared to work and to harvest this data. And only then, of course, come the famous commercialization and the work with the business. Without skillful people, without investments in universities, I think that we'll have a further backdraw on the European competitiveness. That's why the vision and policy, of course, of the Bulgarian Ministry of Education and Science is first and the most important to support our leading centers of excellence, such as GATE, to create much more synergies with Horizon Europe, providing different type of not only funding, but basically boost research organizations and universities to praise and to introduce internationally recognized criteria for excellence in their work, but also in the career development of people. And last but not least, it's difficult indeed, but our ambition for the next program period is to invest much more in academia business partnership, which has a variety of different scope. And this partnership shouldn't be seen only as universities delivering to business, but something much, much bigger. And especially in artificial intelligence and big data, I think that in the core of this partnership should be, of course, the human resources and the skills. Sylvia, dear colleagues, I'm sure I can say much more, but on the other hand, I'm also eager to hear you and, of course, to keep the agenda so that we can enjoy later the amazing presentations of this great team. So once again, in the end of 2020, I wish you to keep the spirit, to keep up, because a lot of work is coming. Thank you so much.
Yeah, thank you very much, Deputy Minister Angelieva. So we are very grateful of your personal and institutional support to all Center of Excellences, especially to our center, and hope we'll prove that we deserve this support and we'll have good results. Thank you very much, and thank you very much for your time. And now, because Peter is still not online, maybe the connection is dropped out, so I will share my presentation. Yeah, before we move to the first panel, I would like to present you what we achieved during this first year. Very short. So GATE is an investment in people. And during this year, we succeed to attract 29 researchers, 16 of which are early stage researchers. And we are in total 38. And with a strong campaign, for recruitment campaign, we attract young researchers who graduated abroad and returned in Bulgaria, so we tackled the brain drain problem. And also we are addressing the Bulgarian diaspora with the experienced researchers who are supporting us. Also we are doing research in, as I mentioned, for research and innovation in 4 application teams, future cities, digital health, intelligent government, and smart industry. And during this year, our research results were published in more than 10 publications, and we demonstrate that we increase our capacity to compete for funding. We submitted 15 proposals, and 5 of them are already funded, and we're expecting results for 7 more. And those projects which are running are in the area of digital twin modeling, personalized medicine, data interoperability, cybersecurity, and explainable AI. And we are working in cooperation with many stakeholders, and during this year we increased our partnership and collaborations. So we intensified our collaboration with SAP Bulgaria, Bosch AI, and Real Solutions and Ton2Text, who are committed to GATE. Also, we become more active, and we are members of Big Data Value Association, International Data Space Association, and Open Geospatial Consortium. We already had, but we increased our memorandum of understanding with Sofia Municipality, Sofia Plan, Medical University, DeepMind for a scholarship, and others. And we were very active. We organized 8 events, the research workshops, and other open days, information days, and we participated and presented GATE and more than 30 events during this year. And all these people on the research topics and collaboration with our partners, we need research infrastructure, and during this first year we are ready with the design of the new sustainable building, where the open innovation labs will be, and well, it's a bit yeah, this is the view of the building, where the open innovation labs will be open for students and collaborators to demonstrate, to experiment new technologies and new solutions. So it's a very short summary of what we did this first year. And now, Peter, are you here? I saw you on the screen. Yeah. Okay. So welcome. The floor is yours for some welcome notes to us and to our audience.
Thank you, Sylvia, and good morning, ladies and gentlemen. Apologies for my delay. I would love to be in that beautiful building now, which would also facilitate our communication. So, first of all, for me, it's a huge privilege and honor to be part of your celebration this morning. I'm learning something new, and I'm looking forward to many more contacts between you and what I'm doing in the Research and Innovation Department of the European Commission. Let me share a couple of thoughts of what to expect from the EU on artificial intelligence in the coming months and years. So I think in this circle, it's clear that artificial intelligence is probably one of the key technologies of our century. We have seen a huge acceleration in terms of computing power, management of data analysis, and a huge array of application areas. So there is a new dynamic, and that has led at European level to a very clear and shared policy ambition that we want Europe to be the hub, the global hub for artificial intelligence made in Europe. And that means made in Europe, that it corresponds also to our values. and that requires excellence, and you are a very good example, excellence and trust. So how to get there? And that is, I would like to mention briefly four points which on which we are working. How to position Europe as a global hub for artificial intelligence made in Europe. The first one is the right legal framework. It is clear that we need to set a frame which empowers any actor, university, innovator, companies, to exploit fully the potential of artificial intelligence, but within the right framework, within an ethical framework, within a framework which allows to avoid pitfalls and traps, to avoid misuse, to secure privacy, and fight bias. Probably something we underestimate globally. Also, given the male dominance in the leading tech companies, is the gender bias in AI as it is currently developed. So we have started last year a white paper with a reflection on artificial intelligence for this legislative framework. And we hope to, we plan to come up with a legislative proposal for regulation on artificial intelligence early next year. What comes out clearly from the wide consultation is that we need to distinguish between applications of high risk, where we need a higher scrutiny, and other applications. So this will be our proposal for spring. We also need to look at how to protect efficiently intellectual property related to AI, and make it possible to protect investments and then to bring the developments on the market. And this is also a strong basis for excellence in artificial intelligence. Secondly, we need the right infrastructure. After the legal base, the legal framework, we need the right infrastructure. And let me give you an example on high performance computing. This is high performance computing is the DNA for successful artificial intelligence. There's a nice project called Escalate for COVID, which has given access to supercomputers in 7 member states. And I'm very happy that Sofia University is part of this consortium. And these supercomputers have altogether 120 petaflops of computing power. So it's not modest. They have been testing within this project, within this consortium, 400,000 molecules about their efficacy concerning blocking the replicability of the COVID-19 virus. And they have identified one which could really be the basis for a drug which could treat, no, it's not a vaccine, it's a drug which could treat COVID. So a wonderful example about the power of artificial intelligence in the health area. But it requires high performance computing and supercomputers. And this is kind of an infrastructure we will invest in also in the future under the Digital Europe program. So with European funds, part of the infrastructure, second element of the infrastructure are data spaces. We have a data space ambition policy in order to share data, make them also findable, accessible, reusable, and curate data. That requires also investment and an important part of the infrastructure. The third element, and this comes now very close to my heart, is investing in research and innovation related to artificial intelligence. in terms of science, Europe is very strong. We lead the high impact scientific publication on AI. Our share is globally 22%. We are not as good as regards applications. So if you look at patents, there other countries or continents are better. The US has a 45% share in AI-related patent, China 40. So there we have some catch up to do. But we came to a very clear analysis that in this big dynamic I mentioned at the beginning, the EU or any single member state, even the biggest member state of the EU, is not competitive. We can only succeed in this very fast dynamic if we act together. And something extraordinary has happened, that the member states have asked us, the Commission, to come up with a coordinated plan of action on AI investments. And this is what we have done. So we have joined up forces with national investments from all member states and the EU investments under this coordinated plan, with substantial amounts of investments to come. This plan is currently, we had the first generation of this plan in 2019. We will update it now in the coming year. And I think it's a very important element also for you to see there will be substantial investments coming. And I'm very glad to see that the Bulgarian plan national strategy for artificial intelligence is based on this analysis and these priorities and takes them further. My last and fourth point is about smart investing, and it's about creating networks related to this coordinated plan of action. From the European side, we would like to see centers of excellence on artificial intelligence to be generated and to become stronger and stronger, so that we become this global hub for AI made in Europe. And there are first networks of networks. One is called Alice, the other one is called Claire, which bring together different nodes of excellence across Europe. And I think that is something where you can play a stronger and stronger role in the future. This is what I mean with smart investments. So I would like you to, and Silvia, really, I would like to engage with you. You have a standing innovation with your colleagues to come when we can travel again safely for a cup of coffee in Brussels, good coffee, to see how we can engage in applications related to my area of responsibility, which is advanced manufacturing, advanced materials, where we can see how we can use more with data and artificial intelligence. So I wish you a wonderful first birthday and many, many happy returns. Welcome. Let us do this excellence in AI made in Europe together. Thank you.
Yeah, thank you very much, Peter. Thank you for useful information, and you made a good for the data spaces, which is our first panel, and also for our Center of Excellence for the future. Thank you very much for your support, and definitely we hope soon we can travel and meet in person, and I'm sure we will come with great ideas for the future. Thank you very much for your time. And now it's time for our first panel, which is Big Data and AI. And it will be moderated by Edward Curry, who is leading researchers in Insight Center of Excellence on Data Analytics. Also, he's vice president of Big Data Value Association. But most important for us is that Ed is chairing advisory board of GATE and is a good friend. And also, I think that this first panel is a panel of friends, people who were involved in the preparation of GATE proposal to European Union funds. And for example, with Ivica, we are friends from and working together with more than 15 years. And currently, he's member of GATE executive board. Also, Torsten helped us in the preparation of business plan, and now is a big great GATE supporter. And Georgi from IBM Bulgaria, he was responsible for elaboration the memorandum of understanding with IBM Bulgaria, but now he's leader for the country and has a power and wish to support us to make this memorandum of understanding real. So Ed, please, the floor is yours. Sorry about delay, but I hope you will manage.
No problems at all. Thank you very much, Sylvia. Can you hear me okay?
Yeah, great.
Perfect. And can you see my screen?
Yes.
Perfect. Fantastic. So welcome everybody to our first panel, which will be on data and AI, and we'll be talking about data spaces. The first part of this panel, I get the honor of having a presentation to kind of set the scene, to set a keynote, which is a wonderful honor for myself. And it's just really fantastic to be here today at the birthday celebrations of GATE. It's really fantastic to see the center growing and now taking its first steps onto the stage, the European stage, and really collaborating and seeking opportunities to work across Europe. So what I love, when I talk about GATE, I love to talk about Europe being at the heart of GATE in everything from its idea to its nucleus, but it's been a very Bulgarian adventure as well. So it really is fantastic. So today, what I want to talk about is how data spaces will power AI in Europe. And we're going to start off, as you should, with a keynote with a provocative statement. So this is a quote from a very famous author. It's actually William Gibson. He came up with Neuromancer. If you've seen the film The Matrix, it's very much kind of based on that world. He coined the term cyberpunk. He coined the term cyberspace. And he has this famous quote. And he talks about the future is already here, and it's just not evenly distributed. And when people think about this quote, they often think about, the power to create the future is with us. We can do this. And that's very true. But Gibson's an interesting kind of guy. And when you look at this quote, there's actually some nuances to it, because there's other things here as well. The future is already here. It's just not evenly distributed. It means not everyone has the same level of access to that future. It means maybe the future has been set by somebody else in a different part of the world with different priorities and different values to us. It also means there's challenges around access, inclusivity, fairness of access to that future. So this is it's a deep quote. It's not just about invention, but there's some more societal context to it as well. Within the context of AI, we know that people talk about data being the most valuable resource now in the world, and how data is the key to AI, it's the key to driving AI. And we've heard this before. But we also have a challenge with, well, who owns the data and who controls that data? Is that data evenly distributed? Well, this is an interesting article from the Economist from last year, and also similar articles in Forbes. And they specifically talk about the challenges that we have around the barrier to entry around data, particularly around SMEs, smaller organizations. If you want to create these AI systems, you need to have access to data. You need to have fair access to data, or else you will not have the competition, you will not have the innovation, you will not have that growth evenly distributed across everyone. So that's really the foundation of my talk today. What I'd like to talk about a little bit is where we're going in the future. So we're all talking about smart environments. GATE and in the talks today, we'll have multiple presentations on smart health, smart energy, smart cities. We all understand the future will be about ICT, helping to manage our world, to make buildings smarter, to make energy smarter, water smarter, city, agriculture, all of these things smarter. But when we look at these systems, as technologists, we know that the key challenge here is actually bringing together all of this information from these different systems that have been created. So for the connected car, it's not just about the car itself, but how it connects to the infrastructure, how it interacts with the passengers to deliver information to them, whether it's navigational aids, whether it's personalized entertainment. It's about the ability of society to create value-added services on top of this information that's been created to optimize the usage of the overall fleet of vehicles that we have in society, to have things like new types of business models around how we insure and how we actually require mobility services. So this is an exciting thing. But as engineers and technologists, we know behind this, there's an ecosystem of systems. And this ecosystem has independent systems that have been created that need to be brought together. If we talk to our friends in the systems engineering community, they talk about building systems of systems, the challenge of how do you bring these systems together into a coherent system of system so that information can flow between them so that we can create this, this vision that we have. So the key challenges that I see from my perspective is that we have major interoperability issues. These are on the protocols, and there has been a lot of progress on protocols in the last couple of years. But the elephant in the room is the semantics. It's basically how do you get that, once you translate that data between systems, how do you get it to work together? And semantics around interoperability is still a significant unsolved challenge at scale. Let's take an example. So we work in the big data PPP, and one of the lighthouse projects that we had was transforming transport. And this really was an incredibly successful lighthouse project. It won many awards. It brought together pilots, I think 22 pilots from across Europe in the mobility and logistics space. It really was a very, very successful pilot. And I would say it's at the state of the art of what corporate enterprises are doing today, the traditional enterprises in terms of digitalization. One of the kind of key messages that they identified in transforming transport was this gold mining metaphor that they had. They start off with the raw data, and they moved it towards insights and been able to extract value from that data. And we can see here on the left, the value that you get in these early stages as you extract the data, you evaluate it, you select it, you prepare it, get it ready for machine learning, etc. The value isn't that high, but the cost of investment is quite high. And in transforming transport, within just that project, they had 164 terabytes of data, over 160 data sources across all of their organizations. They use state-of-the-art techniques in terms of data catalogs for, we'll say, enterprise-level data management. But what they really identified was this challenge at the start of the investment. Most projects fail here because it requires this initial investment before you get to the value return stage. So the return investment is a difficult thing for businesses to grapple with and to be able to work with. Within transforming transport, they came up with this analogy of the sieve. So how do you work with your data assets through different levels of maturity to start off with understanding what data you have. Then you have, we'll say, you a smaller set of data assets that you understand very well, that you know there's value. And then finally, you end up with a smaller set of very usable data assets. This is state of the art in enterprise data management today. They've done a fantastic job. It really is a great project. But I want to step back and I want to think about this future that we have, this unevenly distributed future. This is what transforming transport was doing, right? And this is what most enterprises in the world today, most enterprises in the world across the globe are doing today. They have their pan, they're out, they're looking for their pieces of gold, and they're very, very happy when they find these nuggets of gold. Yes, we've got some value. Yes, we're going to make money. But when we think about those big data enterprises, the really large data natives, they work at a different scale. They don't have pans. They have these types of machines. They come in and they have industrial level mining at a level that we can't even contemplate. Now, this isn't every organization. There's maybe 10 to 15 organizations in the world that are doing this, but they're doing it at a scale that we cannot even imagine. And this goes back to, again, is our future. The future is here, but it's definitely not evenly distributed. So what does this mean? Well, we all agree there's lots of data. It's been created everywhere. We're good at, as enterprises, we're good at understanding about where data can be generated, how we can analyze it. So we understand these data sources. We understand the oil analogy. As we saw in transforming transport, we're also really good at taking data and putting it to work, particularly in Europe. I think we have a great domain understanding, a lot of expertise, world-leading expertise in different domains. And if we give those people data, those practitioners data, they will put it to good use, they will create value out of it. But there's something missing in the middle. We're missing these data platforms. We're missing the logistical part in the middle that helps us move the data from the source and give it to the decision makers. And we're missing that in the ways that those large organizations have industrial level data infrastructures. We don't have that. We're out with the pans in the stream looking for these nuggets of gold. We haven't got to that industrial level analysis. So what does this mean? Well, What it means is that we need to start thinking more about data infrastructures and what we can do to support our overall infrastructure. There's a lot of talks about data spaces, data platforms, data marketplaces, and all of these are things that we need to investigate and figure out how do we arrive at this industrial level exploitation of data. A couple of interesting examples. Airbus actually managed to deploy themselves an end-to-end data platform across their supply chain that incorporated their customers, their suppliers, their business partners, and they've shown an example with Skywise of how they can bring together a sector around a large corporate to be able to share and to start looking at how they can maximize the data across their supply chain, across their vertical and horizontal industries. Very, very nice, interesting example, driven by a large corporate that had the power to be able to do that. At the other end of the scale, we have examples of where data platforms have been deployed within single organizations. So for example, we had a project with Milano Linate Airport, where they actually deployed a data space to help manage the energy and water management around the airport. Airports are like small cities, so it was effectively like a mini smart city, and they were able to effectively set up data sharing between their different stakeholders to improve water usage, to be able to improve energy management. As part of that project, we actually developed some work on real-time linked data spaces, and what this is really showing is that it's possible to create this at large scale, but also at small scale as well. The key here is the enabler. How do we create enabling data sharing technologies to be able to help organizations move the data from the generation to the decision maker or to the person who can extract value from it? But where does this leave us? What are we going to talk about in the remainder of our panel? Well, we know that we need some form of data infrastructure. And I believe that when we look at it today, Europe is one of the leaders in open data. And I believe that we need to start thinking about what do public data infrastructures look like. I firmly believe that forward-thinking societies will see the provision of digital infrastructures, including data platforms, as a shared societal service in the same way that we see water, sanitation, healthcare, education, mobility, transport as this shared societal service. We will also expect our society to have digital infrastructure that we can all access. People tell me I may be crazy about this, but I'm going to give you a very quick example of where we had in the area of COVID. In March, we didn't have any public data infrastructure for sharing pandemic data within Ireland. And very quickly, in the space of a matter of weeks, we managed to create ourselves a COVID-19 data hub in Ireland. We were able to quickly get all of the stakeholders sharing information, and we've had over 100 million data set downloads since June. Now, Ireland has a population of 4 million people. We have 100 million downloads of this data. That shows you that, one, the public sector in an emergency can respond and provide digital infrastructure, and two, it tells us that people are really interested in data. This is the COVID tracker app that we have in Ireland. It's very popular. It was developed through the public sector working with a small SME, was developed for under €1 million, well under €1 million, and it's actually been used in multiple places in the world, including New York State and a number of other states in the US. Everyone in Ireland is looking at this app, looking at the cases, looking at all of the different data that's been collected and shared. We can do this. We can create public data infrastructure. A little talk, a little mention on the European data strategy. I won't talk about this too much because our previous speaker mentioned it, but I think it is my belief that we're starting to see this as well within the strategy from the Commission. I believe our friends in the Commission also recognize this need for public data infrastructures that are there. In the interest of time, I'll move on to the notion of common European data spaces. I think this is definitely the seeds, the start of this conversation around public data infrastructure, where the Commission want to create these common European data spaces where these different sectors can start to look at how do they share data. It brings the sector together to have the conversation to figure out, well, what will this infrastructure look like? And potentially, in my view, each of these sectors may have a different style of infrastructure. The key is how do we get all those infrastructures to work together, or at least how do we mediate between them? But the important thing is the conversation is now starting, and this is a role that we can play and that GATE can play in that conversation. Another slide I'd like to just briefly present is from the Big Data Value Association. So in response to the European strategy, we have done a position paper on what it would look like to have European governed data ecosystems, data sharing spaces. And one of the key things here from this is that the challenges around these common data spaces is a technology challenge, but not only a technology challenge. We have other critical issues in the area of data governance, of engaging people and educating people, creating the skilled people at both practitioner, domain experts, but also technology experts. We need to understand how this changes organizations, how it changes business models. But most fundamentally of all, the biggest challenge here is trust. And how do we have trust in the data, trust in the infrastructure, trust in the governance, trust in the protocols around these data spaces? This is an absolute key.
Because Thorsten have to leave, can you switch to
Sure.
him?
We
Speaking
can.
about data
I'll
spaces.
skip to my last slide.
No, but we'll continue then.
Well, I've only got 2 slides. The last slide is to say there is a European partnership on AI data in robotics that will be trying to lead this charge as well. And really, as my last slide here is, the future is already here. And what we need to do now is to make sure that we evenly distribute it. And with that, I'm going to hand over to Thorsten, and then we can start our panel. Sorry, Thorsten, if I was taking a little bit too much time there.
No worries. So first of all, sound check. Can you hear me?
We sure
Yes.
can. Do you want to share your screen as well?
Yes, one moment. This works like this. Now you should also see my presentation, and I will put it into presentation mode. So now it should be fine, right?
Yes, great.
Yes.
Perfect. Thank you very much. So yes, Ed, thank you very much for this very good introduction and also bridging between my short input and the input of Peter Droll, because I think it fits very nicely. And I want just 4 or 5 minutes talk about trusted and sovereign data sharing spaces as enabler for AI and big data. So I am Thorsten Hülsmann. I'm one of the 2 managing directors of International Data Spaces Association. It's an association with some 125 members from 22 countries, and it was established in 2016 already. So the thing which what Ed just described, the distribution of data and access to data, could also be seen from another angle, from another perspective. Well, it is a little bit the contradiction between interoperability and data exchange or data sharing on the one hand side, because this is what most companies and research activities focused on in the last, I would say, 5 to 10 years. And of course, this led to all what we are discussing about in the sharing economy and about data-centric services. But on the other hand, what is also true, and Ed mentioned it briefly, and also Peter talked about this, companies do not necessarily want to share their data. And especially, I'm coming from Germany, from a region which is called Sauerland, which with a lot of SMEs. Well, they are pulling things and they are producing steel parts, and well, they are very conservative. And these companies never ever would share any data which would give insights into their operations. And therefore, the topic of data ownership, data security, and data value is becoming more and more important. And I think we witnessed this. In IDSA, it is an industry-led initiative. In 2016, this topic was discussed heavily. And well, what we defined afterwards is that data sovereignty is the key issue when we are talking about this dilemma. Data sovereignty not understood as the notion where data is saved. It could also be understood like this, but data sovereignty understood as the ability of a company, of a natural or legal person, to exclusively and sovereignly decide concerning the usage of data as an economic asset. And this then, if this data sovereignty would be placed in the middle, would enable companies to link their data without regret. And so I'm not an AI expert, but I would say I'm an expert, an enabler, and an enabling expert to help companies. And this is exactly a summary. So when we are talking about data spaces, one could also understand data spaces as clean rooms for a prospering data economy. So we are talking about governance for data sharing, like Ed described. We are talking about usage constraints. We call it usage constraint. And usage control, and we are talking about trusted manipulation of data. So this is also important when we are talking about data spaces. And rightly also these 3 topics which have been heavily developed and investigated by the members of our association in the last 3 to 4 years, standards for data flows between all kinds of data endpoints. This is what an unlimited interoperability means. So with this, we are talking about peer-to-peer networks, data spaces as peer-to-peer networks, linking and relating, for instance, data platforms and data markets. We are talking about trust between different security domains. And with this, IDS already worked intensively about comprehensive security functions, providing a maximum level of trust. And of course, we are talking about governance, usage control, and enforcement of legal requirements and legal contracts, technical enforcement. This is what also is in the debate. And if we just envisage, for instance, a manufacturing company with a lot of, let's say, companies related together, which are, for instance, linked via enterprise cloud systems or industrial data clouds with data marketplace, IoT clouds, or open data sources, we can see on the one hand side normal data communication flows, which are here described with this black lines. But on the other hand, there are also communication flows where certain usage constraints are necessary. And these are described here with this white communication lines and the IDS connectors in between. And this is exactly what we understand as a data space. It is just one of thousands or millions of data spaces. And by proposing a specific software component, the IDS connector, industrial data clouds, for instance, can be connected as well as individual enterprise clouds and on-premise applications and individual connected devices. So IDSA at the very end is a standard development organization and an organization or an association which develops currently and also maintains a certification scheme for this trust activities. And also very nicely linked to what Ed already had in his input, the 9 data spaces in the key sectors, which are proposed by the European Commission. And I think what first is done is right, concentrate on the domains as such, but the real value comes if we are talking about connecting the different domains, because we do not want to have in the future platform silos. We want to enlarge the data pool and we want to have cross-sectoral benefits. I think this is what data spaces are really about, and this is what is very interesting. What are the contributions of IDSA which have been achieved in the last 4 years? I think conceptually, there is this movement, I would say, this initiative on data sovereignty. Technical, we have the reference architecture model version 3 already. We have a standard started in the German DIN Institute, which is now transferred into an ISO standard. We have a very interesting and active community of actively participating companies. And we have a global reach, as we are also very intensively collaborating with Japanese companies, for instance, Japanese institutions. The Americas are involved. So these global liaisons are of high importance. And the certification scheme, which I already mentioned, a formal certification which states coherence to reference architecture, interoperability, and software quality. And finally, well, we need support, and therefore we started already 2 years ago to create IDSA hubs with 7 countries. We already have formal agreements. I come to this in a minute. And finally, also, when we are talking about this virtual data infrastructure, data spaces infrastructure, which IDSA is focusing on, we also are involved in the endeavor of Gaia X, which is more than bringing the cloud environment into this game, the cloud environment for a federated data architecture. So these are the contributions of IDSA. And finally, let me just mention also the IDSA hubs, because also today is a day to to celebrate that the Gate Institute is our 7th hub, just set up in Bulgaria. And Sylvia, I think this really starts within the project of setting up and establishing the GATE Institute. I think it was already 2.5 years ago when I participated in the EDBA forum in Sofia, and where we well talked about how this could be brought together. And now 2.5 years later, we finally signed the contract and the agreement to GATE becoming the IDSA hub in Bulgaria. This is very interesting and very good development also from IDSA perspective. So this was my input, very short and precise. Data sharing is better than playing alone, but we should stick to certain rules to guarantee data sovereignty. So this is my initial input. I have some 10 minutes more time before I have to leave for our own General Assembly, which takes place today at 10:30. So sorry if I later on just sneak out of the session, but this was my input. Ed, back to you.
That's great, Thorsten. Thank you very, very much. If I might start with a question maybe for yourself or maybe to Sylvia, if you could maybe elaborate a little bit on some of the plans that you have for this hub for IDSA in Bulgaria. I think it could be interesting to learn a bit more.
Yeah, definitely. So maybe I started, Sylvia can complement. So the reason for this IDSA hubs is that we just need support in the association to reach out to companies and really to well, to transfer all the knowledge which is elaborated in our working groups into the industry. And therefore, we decided already a couple of years ago that we primarily will have only one hub in each country, which is then the national IDSA workbench, so to say, with the goal to transfer the IDSA activities into the country in question, to talk with also the governments to align the different national supporting schemes, but in first instance to reach out and to train companies and to transfer knowledge. Maybe Sylvia, to complement from your side?
This is especially important for Bulgaria because we are having application domain smart industry, and we are behind the first year. We didn't pay so much attention on this, and thanks to this agreement we have with you, we'll develop further this domain in Bulgaria and to train the companies and ask them to become members of, and with all the benefits to become members of International Data Space Association, to share data, to trust each other, and to get this value of data for their business, which is very much needed in Bulgaria. So I'm looking forward this real collaboration, and yeah, we'll also contribute to your architecture, to the components. I believe we'll have skillful people to contribute also to this. So thank you.
Perfect.
That's great. Thank you very much. What I suggest in the interest of time is that we can maybe look to our next contributor. So next up is Professor Ivica Savrinkovic. He's a professor of software engineering at Chalmers University of Technology, Gothenburg, Sweden. He's director of Chalmers AI Research Center, and his research interests are in the development of complex software systems, and recently in the area of data-driven and AI-based development of such systems. He's going to present today on the challenges in the development of data-driven AI and applications. So Ivica, I shall pass over to you. If you can just unmute and we can see your screen.
Yes, thank you very much, Ed. I hope you can hear me and you can see my screen. So excellent introduction. So I'm not surprised, but I'm still impressed by how similarly we are thinking about seeing this need and for the opportunity which we have. But what I want to say here presented is slightly about the challenges in managing data and building this added value. What kind of challenges you have. And I will start with one known paper which was produced by the Google about machine learning, or how to build this added value, what gives you the new values, and that's what everybody is impressed of, and that's this machine learning and building up the modules which is based on data. But if you look at the entire procedure, what you have, then you can see that this building the code, building this intelligence, it is extremely small part of the all the activities. you need to have, and infrastructure. And this infrastructure and managing data is one of the most difficult part. It requires most efforts and resources, and there are many problems. So we really have to solve all these problems to be able to make this one. And today is the situation that only the biggest companies can do this, the entire chain. So I would like to show you a few examples related to data about the challenges. And one is related to the value of the data. You know, so suppose that we even have possibility to reach the data and then use for some results. And then I will show you one example from Wikipedia. You know, Wikipedia is like a great source of text. There are a lot of pages and a lot of text, and there are many systems now using Wikipedia as starting input data for building their models. And then you can ask, for example, okay, how is the distributions of data or articles in Wikipedia according to the languages? And then you get these results. Of course, English is the first one. Everyone knows that. So it's really a high number of articles. But then if you look what is the second, then you see it's Cebuano language. So maybe you have not heard about that language. On the third one, what do you think? What is the third one? And that's actually I want to solve. It's a Swedish. And that's kind of surprising because Swedish, you know, Swedes has 10 million people. It's much less than the entire world, but it's third on the list. And then it comes other countries. How that's possible? So if you look at explanation, then you can see like it has so many articles where majority are generated by a bot. And it's about 95% is generated by a bot, and not only by a bot, but most of that is generated by one person. That's one researcher who is translating and using different sources of data, putting in Wikipedia. And actually also Cebuano language is the same. It's another researcher and it's actually a pair from Sweden, man and wife, and they are producing this data. And then you can ask a question, okay, what is actually the real value of this data? What is the accuracy? What is the trustworthy? What is the relevance? And of course, that case is done in a proper way. You know this translation from English Wikipedia's pages and so. But still, I want to show here that even if you have data and you have open data, and the data which have to go through strict procedures of controlling, you still there are really challenges to see what is the real value of data and what the data is presenting. The other example I want to show you is related to one case which we had here in Sweden, and that was idea to build up a prediction system for loading of and capacity of hospitals to predict how many people will need help related to COVID-19. And the idea was to do it for the region Västra Götaland, which is like on the west coast on the Sweden, and then also in the region of Stockholm. And the idea was, okay, to get data from these regional centers, which have all data related to hospitals. You know, people which are coming to hospitals, registers, but also emergency calls, ambulance, and so on. So it's really big data. Then, of course, there was the data from hospitals themselves. That data is not integrated with this previous data. It's like internal data on the hospital. So it's about patients, about logistic data. So And that idea was to combine, to see how that is combined with the movements of people and how they are getting together and related to some social events. So the idea is, of course, take the data from mobile phones to see the people mobility. And there are different telecommunications providers which are ready to, which were ready to give this data, but that data, of course, was not completely. It was done only in a number of people at the place at a certain time, not personal data. And that everything was collected by Ericsson, because there are different providers, and these different providers have their own data. And finally, the Chalmers researchers want to build a model. And so we have met really a lot of problems here, practical problems. First was to get data from health due to this sensitive private data. So there are strict rules, and simply it was not possible to get data. You know, on just actually we succeeded to get in Gothenburg, like signing the contracts, all the project partners which have been there, not to use the data in just in particular case, but we never succeeded to get from Stockholm region, even if there are like the same rules, they are interpreted differently. And of course, the mobility data, even if it was available, like very detailed data, only part of that was allowed to be used, so that actually the results were not so accurate as we wish to have this. And of course, it was very difficult to validate the results because also to access to the data was not really on the real time, but with some few weeks later we would get the data. So this is one example how difficult it is to collect the data, even if the purpose is very, very clear. So what I want to say here, to conclude with that, what Peter and Ed have said. So we have a lot of challenges, and but we have to solve these challenges in some way. These are related to ownership, to the privacy, ethical principles, to the business value, accuracy on the real semantics or real value of data. We have a number of technical challenges which we have to solve in collecting data, in this data, different formats, accessibility, and so on. And in general, I would say at the end, when you are coming to the programming, then you're coming to some basic principles, and that is this machine learning. It creates algorithms, models, but you never know how long these modules are valid. When you change the context, that model, it can happen that is not valid anymore. But if you don't have a control about which data has been used to the training, in the training, and related to the when it's used for new prediction, then you can run into trouble and come to the completely wrong results. So which at the end can lead to lack of trustworthy of such systems. So there are a lot of principal challenges, and there are a lot of technical challenges, but many of the challenges can be solved. So of course this requires a lot of input and efforts, and that's very nice to see that EU is putting such efforts in addition to industry, which also is doing that. Okay, that was my short introduction to this.
Thanks very much, Ivica. I'm going to ask you a question on just the last thing you mentioned there was trust. And to me, like trust seems to be the, it almost seems to be a panacea type thing where like everyone says we need it, but then when you dive into it, well, it's very complex, and it goes, I think in both the examples you gave there, you talked about the technical trust in the solution. So it's going to be, do we trust these software systems that we're creating? And then in the previous example about data sharing between the two different regions in Sweden, it seemed that maybe there was more trust in one region that what you were doing was okay, and there was maybe less trust about sharing the data in the second region. Could you maybe elaborate a little bit on the notion of maybe your experience that you're seeing around trust, whether it's the software system or the ability to share data?
Yes, I think what I see, what I hope it will happen in the future, that more and more data will be available, like open and manageable data, as you have mentioned. We have passed this process. So like typical e-health like data from different diseases and so. Many hospitals have a lot of data. This data is not integrated. But if we manage to integrate that, and if you manage to make them open, that then the trust will increase for such data, because there will be so many actors who will test this data. So this work on the openness and integration, it really must be encouraged. I know we had a discussion at the hospital. There was discussion, and some people say we should open our data. The others say, no, we cannot do this for privacy reasons, and it's also business value. But I think that the institutions which have, which are like public institutions, they should really have also a goal, and maybe they should be encouraged also to provide available this data. That's one of the things, and that will increase the trust, I think.
Yeah, I think it's a learning. It's a journey we need to go on together to understand what it means to share data, and I think it's a great opportunity for public sector to show leadership in that as well. So
yeah, exactly,
guiding light, and to show that these approaches are acceptable, and best practices can be developed in that space. I think it's a fantastic opportunity. Just back to the first slide that you presented, you showed that complexity of systems that are being created, how ML is only a small part of that, machine learning is only a small part, or AI is only a small part of those systems. Do you think companies will be able to tackle this? It seems almost insurmountable. Like, what are your thoughts on how they should go about that?
So if you see a situation today like this, the biggest producers of AI systems are like 5 companies. So even in the US, they don't have these capabilities, and that's really. So this democratization, or what you have mentioned, that we have to build this future, is extremely important. This infrastructure is the biggest problem, and not only small SMEs, but also medium-sized companies and even larger companies have problems with build up such structures. So the emphasis to putting of this, make possible this infrastructure, as you mentioned, like water or electricity, that's really extremely important to build up. Otherwise it will, because now there is a lot of data open already today, but they are they are maybe not so important. You get a lot of pictures of birds, and that's okay, that's great, but this is not the only data we need for further development. So EU should probably encourage even companies to open data.
Okay, that's great, Ivica. Thank you very much. And actually, that leads us nicely to Yuri Ganav. So Yuri actually comes from one of these companies, one of these large companies that create world-leading AI systems. And Yuri has experience from different areas of business. In the last 16 years, he's been working in IBM. He's worked on finance, business consulting. He's focused on organizational change and transformation, things like sales, leading software and analytics businesses, working in enterprise sales, and he is the country leader now for IBM Bulgaria. And Yuri's going to talk to us about the challenges of AI and how this relates to Gate. And hopefully he might touch a little bit on what it's like to work in an organization, one of these large industrial strength organizations that are extracting value from data and building world-class AI systems. Yuri, the floor is yours.
Hi, Ed. Thank you for having me. Thank you, Sylvia, for the invitation. I hope you hear me well. I think I was thinking, shall I put slides, but I decided not to because I think that colleagues covered many of the topics, but I'll try to elaborate on them. And I'll try to link first to Ivica with the first challenge around data. And this is around, Ed also touched it, it's around accessibility and availability of data. And is that equal? Is it so easy to access data? And second of all, if you remember the picture of Ivica, how data moves to get to the value and to build a system, and how big was that? You think about also from where you extract and take that data. And this was said about a lot already, and because there are lots of data silos. Data is there, but there is a lot of data silos, lots of different options to get data. So nowadays, this is one of the biggest challenge, actually. I mean, how you move this data around. And this touches the infrastructure story, because you need to put it somewhere. But there are also other trends lately that are addressing this issue. And this is more about the data virtualization. So moving less and less data around, because even if you look at the job of the data scientists today, and these people that are producing the added value at the end, I mean, most of their time is still about crunching the data around and moving it, getting it together, using the right data, ensuring quality. And in today's world, after we're talking for more than a decade, I believe how important data is, and about this, I refer to the picture of it with the new oil or new electricity. Everyone calls it differently. This is somehow showing you that, you know, still we are having challenges, because it's hard. The time to produce a result, it's a long time. And I can give you an example with customer of ours who was looking for real-time scoring of their customers. You come, you apply, it's a bank for credit, and they tell you yes or no immediately. This was the goal. This took them a year and a half. Year and a half. Models were built quickly. You know, they knew the models were right, but putting the data together, the right data, to make sure quality of the data is there. I mean, you know, dealing with all the IT internal challenges and whatsoever to get access to the right data. Even their one organization, this was taking most of the time. Let's put it like this. So this is the first challenge. I mean, how you minimize this data movement? Because I mean, if you continue to move data around and put it in a bigger and bigger repository just to have it at your disposal, you're looking at huge cost. Okay, and you cannot afford it. If it's I mentioned it, many companies cannot. So you would be looking to try to virtualize data so that you have less time to move data around and quicker time to value to get the data at your disposal. The second, I think it was touched by many people already, but this was talent. I mean, talent, it's a big issue around data, and what I see in the organizations, how they bring talent and how they grow talent. And especially, you know, no one wants to do the dirty work, especially that I mentioned around crunching the data around. Everyone wants to do this, call it a nice, you know, interesting ML work, that they will build something and they will have an outcome. People are focused on the nice thing around data science, but there is also dirty work. Someone has to do it. And this was shown very nicely in the picture of Ivica before that. I mean, in today's world, there is a talent issue everywhere. So this, I think, very nicely relates to what our colleagues and friends in Gate are trying to do, because they want to nurture this talent. They want to grow this ecosystem. They want to grow people in Bulgaria and talent, and, you know, to have outcomes at the end of the day. And third and very important one, it's trust, mentioned many times already. Okay, trust and trust was mentioned in terms of the first issue around data silos, and who do you trust to give your data on one side, and how you gain the trust of the other people to get their data. So this relates to governance, security, sovereignty, and many other things that have to be taken care of, and accessibility. But one very important thing, it's at the more or less at the end of the chain, or even in the middle. Two important trends, I believe. One is more about the fairness of data and the models, and how fair the outcome of our model is. Is there a bias in this model, like gender, race bias, or whatsoever? Do we have the right data sets to ensure that there is no bias in our model and the outcome that we produce? And this relates again to what data you access to, what data sets you use, how you manage it, how you ensure that you have the right data set so you don't produce a bias in the model. So it also relates to the other part. And one other very important one, it's explainability of the models. Why is this important? Because nowadays, many colleagues know that the techniques are becoming more and more powerful. They're extremely powerful techniques to produce data. I mean, deep learning and many other. I mean, and they're improving more and more different techniques. But many of them are black boxes. You put something in, you don't know what happens in between. So you need to have a way to explain why this happened. What did you produce? Why did it come out? And this is very important for IE, I believe, because people will trust this model and they will trust the result that you produce for them. And this goes back to trust, because if you produce something that I can trust, I'll take it. I'll use the service, I'll share my data, and so on. So this is like not a vicious circle, but a good circle that I hope our colleagues from Gate will observe in their model. I see this in their, how to say, in their practices, but I hope that they will take that into consideration and will take that forward for the better future and the better results that they will produce. Generally, and I will conclude with one thing. I mean, just to give you an example, and I'll use also Ed's story on that. In Bulgaria, for example, what I have seen, I mean, our customers are very good at uniting when there is a common bet. Okay, common bet like cyber attacks, and then you see customers sharing data in between them in order to beat the certain attack that it's for certain sector or for certain type of customers, and they unite. And Ed gave very good example in the beginning, the COVID data hub in Ireland. I mean, the common bet is against us. People united, they share data and they work. So, I mean, if you think of use cases where you can easily, maybe easier to do something and to progress faster from Gates' point of view, maybe some of the, common bad cases for the society can be a good start for them on that side. So consider that in the future. This would be my advice, because we usually focus on the best and the nice, we want to do it, but then we face all the other challenges behind that. People don't want to share data. If it's mentioned, even if we wanted to get the data, we were not allowed to use it, we couldn't get it, and so on. And this can be, something to consider going forward. This was my short message for today. So thank you for the time.
Thank you very much, Yuri. There's a famous quote from Winston Churchill that says, "Never waste a good crisis." So maybe our friends in the UK are leveraging the crisis now, but I see the wisdom as well. When you have these opportunities to bring everyone together, you can really make giant steps together. Some really, really great points, Yuri. Two things I wanted to touch on, though, because you brought some new elements into the conversation. You talked about skills and the challenges that we have there, and we also talked now about building systems we trust, which requires engineering, requires knowledge of data. In your experience, what kind of skill set is required, we'll say, from the graduates and from the people that Gate is going to create in the next couple of years? What do you think will be important for those people?
What will be important? I mean, look, there are certain areas of building the result of IE, and I think these, if I can, crunch them like this in terms of areas, definitely data architecture is one thing that I see missing a lot and is being committed, honestly, because everyone focuses on this, on the ML, deep learning, and the skills that will produce a good and nice result at the end. But having good data architects, I see this skill very scarce on the market. The second one, it's around the data engineers, I call them, because these are the people that work with the data and make it ready, ensure that it's properly prepared, in good quality. They care about governance and all that. I mean, there are many roles under it, but this would be the so-called group, I call them like this. And last but not the least, I mean, there are trends around, I think they call it differently, data ops, ML ops, doesn't matter. I mean, how you make this working, and this would be also important for Gate, how they organize processes, organization, even way to fail fast. I mean, you don't want to work for a year and a half to realize that you failed and this project will not work. You need to realize this in weeks. So you need to have these small pilot projects. Even we in IBM practice this nowadays, honestly speaking, and with customers. So this is a very important, how to say, skill, how you organize all this process internally in the organization. Yeah, obviously you need to use practices like Agile, and this MLOps, it's close to DevOps, let's put it like this, but in the data space, from that perspective, let's put it like this. That's more or less the three key skills I would be looking at. I mean, and I see
a
stars
really
on the
nice connection with Ivica's first point around the complexity of those systems and all the skills that are required around ML and AI to be able to make it work. Fantastic. And then the final question I'll ask Yuri is, so Gate is now in it's established. It's 1 year old. What are the incentivizations for getting organizations involved in Gate locally? Like what are the things and the benefits that they'll get from being involved, and how can we incentivize organizations to participate in Gate and work with it?
Yeah, on incentives, I would assume is the most focus because people like incentives. I'll skip the money part because I think this is hygiene. Let's be fair. I think very important, and most of the leaders nowadays recognize this. It's recognition, and bringing today's world, expectations to life, like ease of use with good results, fast time to market. So if I give you my data, how will I benefit from a better service, faster time to market, ease of use of any given use case or whatever we are tackling together? So this would be critical for me if I have to make a decision as a user as an owner of data. But this also tackles the maturity of the market, and this would be one of the, I would say, maybe the challenges of Gate, because in Bulgaria, I would dare to say the maturity of people sharing data around, it's not at the level of more Western European world. I'm sorry to say that, but I hope Gate will change that. We were doing a study for how local organizations are using data and AI. It was not last year, actually, exactly, 2019. And I saw that many of them were ready to use external data, but almost none of them was ready to share data. These were two of the questions out of the study, almost none of them. And I was interviewing banking, telco, insurance, government, mostly, these four sectors. And these were, some of the results. So this will be a challenge for sure. So they need to find a way how to tackle this challenge. And I think that's why I mentioned the case for common bet. I mean, think of common bet so that they're more open to share the data so that they resolve a common issue.
Okay, thank you very much, Yuri. I'd like to thank all my panelists, Ivica, Yuri, and also Thorsten beforehand. I think it was a really interesting conversation. I'm going to hand it back to Sylvia. I'm sorry, Sylvia, we're a little bit late, but I think the conversation was most definitely worth it. So
Yes.
back to you, Sylvia. Thank you very much.
Thank you very much. It was really interesting and a lot of truthful for thought. So a lot of things we need to consider in the future, and a lot of good ideas coming from your side. And it's normal that we are together. We're on the same page. We share the same values and the same view of how to develop further. And I think that's one good example. We succeed to sign this agreement with Sofia municipality to exchange data. So it's one step in this direction, which I think if we have one good example, they will follow from other industries, but it needs a hard work. And also for data engineers in Sweden, they have such a position, data engineer, which is not available in Bulgaria. We don't know what is this, but now we will educate people. We are preparing the training courses and research and master program to do this and to prepare such people which are needed in the industry. So thank you very much for your input. And we'll stay together and we'll have more focused workshops on different topics we are working in. Thank you very much.
Thank you.
Thank you.
Now we move to in our program. As you've heard, we will learn about other European Center of Excellences in Big Data and innovative companies. We will start with Insight Center, where it is working, and it is one of the largest data analytics center in Europe, where more than 450 researchers are working, and they undertakes high impact research, seeks to drive value from big data, and provides innovative technology solutions for decision making. Also the other video will be from one innovative startup company, Iris AI. They're very close to my heart because one of the founders is our student from software engineering program, and they recently opened the office in Bulgaria where other very good our student is working with. And this is a company which is with Swedish and Finnish representatives. They created it, and Iris is working and developing AI and ML-driven software, that tools that assisting scientists through their work. And they have a very good spirit. And if I was young, I think I will be wish to be part of that team. So enjoy the videos, and in 11:40 we're starting next panel. Thank you.
So I am Mathieu Daquin, I'm Vice Director of the Insight Research Institute, which is the data science institute of the National University of Ireland in Galway. It's a research-oriented institute working on anything which is related to collecting, processing, analyzing, and basically using data. We put all of this under the name data science or data analytics. We are really at the leading edge of what data science is currently by really pushing the boundaries of research in this area. We are at a stage where our network and our scale, no other organization can compete with at this stage.
AI, artificial intelligence, has become a hugely important research topic for Ireland. It's transforming the world in which we live in and has the potential to impact on many sectors of Irish society. One area where AI has had some very high impact successes to date is in the area of computer vision. That is the discipline of trying to train computers to see and to perceive the world in the same way that we as humans perceive the world around us. AI techniques are automatically recognizing what's a pedestrian, what's a bicycle, for example, what's another car. But ultimately, of course, we want the camera to be able to identify potential behaviors of these objects. So here you're seeing an example of tracking humans, pedestrians in this case, recognizing that they're about to cross the street and then following them as they cross the street. Computer vision, powered by AI, is finding its way into many other industry sectors that we wouldn't have thought of originally. We're looking at using video as a sensor in a farming context and looking at everything from animal health, to cow health, for example, to the quality of the grass in the paddock. Of course, it's extremely important that we prepare the future youth of Ireland to be able to contribute to the AI economy. 3 of the recently launched Science Foundation Ireland Centres for Research Training are very much focused on AI. These Centres for Research Training will produce industry-ready graduates who are ready to hit the ground running and enter the Irish workforce, who are among the world's best in terms of AI knowledge and AI thought leadership.
I believe that human beings have already discovered the solutions to most of our pressing problems. The challenge is that these solutions come in the shape of puzzle pieces. A research paper here, a conference report in Chinese there, a heated online discussion, an internal memo in a corporation, they are scattered. The abundance of knowledge that we have today is unprecedented, but our human minds do not have sufficient computational power to process it all. Or easier said, we can't read and understand everything. Every single day, 3,000 papers are published within science, technology, and medicine alone. 3,000, not to mention the millions that are already out there. So a lot of these resources end up in the digital equivalent of a dusty old drawer. 50% of papers published are read by less than 5 people. That's sad. But what if we had a brain, a really big, really powerful brain that could read and make sense of all of this? Well, that is what we are building with Iris AI, an artificial intelligence that will be able to read all of the world's research and help us connect the dots. What we're doing today, very concretely, is that we're semi-automating the researcher's process. We launched the first phase, which is taking a problem statement and broadly exploring the research field. And we've proven through peer-reviewed open access papers that we, using our tool, researchers using our tool, consistently outperform teams using, for example, Scholar or PubMed, which is very exciting. But the second step of the researcher's process, which is taking all of that content and narrowing it down to a precise reading list, and that is a tool that iterates between the tool and the user to filter down. We can save you 90% of your time in doing this with about an 85% precision and recall, which is a lot better than what you can do in industry today.
In this video, we'll introduce you to the Exploration tool, which provides an overview of scientific knowledge related to your research topic. Start exploring and add a URL to your research paper. If you have a premium account, you can also type in the research question and a description of your problem statement. Write a description of your problem in 300 to 500 words in English. Include the background of the problem, clear research questions, and a description of your goals. If you use specific terms or abbreviations, write an explanation of what they mean. Think of it as explaining it to another human in your own words. When you're done, click Submit. Iris maps out the key concepts, contextual synonyms, and topics of the paper or problem statement and presents them with related research articles. The visual map consists of clearly organized topic clusters. The topics represent contextual categories that Iris has learned by reading millions of scientific documents. The visual navigation shows you an overview of topics and allows you to move around the map easily. By clicking inside the topics, you can explore the individual research papers fetched from the given databases. When you find something interesting, you can review the details, download the paper, and bookmark them for your personal reading list. The relevance score indicates how well the specific article matches your search. At any point, you can find more related papers by generating a new map from this paper. You can also save the entire map for future use. Bookmarking the most interesting maps allows you to use them as a starting point for your literature review using the Premium Focus tool. Check your exploration history and come back to all bookmarked papers and maps anytime from your personal dashboard. The Exploration tool lets you discover hundreds of papers across different scientific fields quickly and effortlessly. And because Iris bypasses keywords and built-in citation biases, you can finally get a comprehensive overview of the knowledge around the research challenge in focus.
With the highly ambitious goals of the Gate Institute, naturally comes a need for performing thorough big data and AI research. We see this as a great opportunity for collaboration and are looking forward to help solving the current challenges in this area through a new way of doing research exploration. And now, a short sneak peek behind the scenes from our journey in the last 5 years.
Welcome to our second panel devoted on Digital Twin City, which is part of our Future City application domain. And the panel will be moderated by Graham Kemp, who is a professor at the Chalmers University of Technology on Data Science, and also he's co-leader of Big Data Research Profile and ICT area of Advance in Chalmers. And also in GATE, Graham is responsible and part of the team which is developing a strategic research agenda. And I hope it will be very interesting discussion on Digital Twin City. The floor is yours, Graham. You are muted. Yes.
Thank you, Sylvia, and welcome to this session on City Digital Twins, which falls within the GATE Institute's strategic application theme, Future Cities. I'm Graham Kemp, and I'm the moderator for this session. Soon we'll hear from our keynote speaker, Jarmo Suomisto, and an international panel. But first, I'd like to present briefly the history of the connections between two young research centers, the GATE Institute and also the Digital Twin City Center, which was established recently in Gothenburg. In April 2018, the Chalmers Initiative Seminar on Virtual Cities brought together academic researchers and representatives from industry and the public sector. And 4 of the participants in today's session also took part in that one-day meeting. But at that time, neither of these two centers, neither GATE nor DTCC, existed. And it was a few months later that a proposal was submitted for phase 2 of GATE, and a few weeks after that, a proposal was submitted for DTCC to the Swedish Innovation Agency. And Sofia University and Chalmers University of Technology were partners in both of these proposals. In the spring and summer of 2019, we learned that both of these proposals had been funded. And a few months after, GATE held its opening event and kickoff meetings in Sofia. That was in October. And at this opening event, we highlighted the participation of GATE in the Digital Twin Cities Center at Gothenburg, and also the connection between GATE and the rest of the big data and AI ecosystem at Chalmers. In February of this year, a delegation of 9 people from Bulgaria visited Gothenburg. And during this visit, we had a joint workshop of GATE and DTCC. This was held on the Chalmers University campus. And researchers from both Sofia and Chalmers presented plans for their respective centers and identified areas where collaborative projects could be initiated. In March and then in the spring and autumn, the DTCC got underway with a kickoff event and then a series of workshops, and several GATE researchers took part in these DTCC events. A couple of months ago, GATE hosted an event on future cities and their digital twins. And DTCC also took part in that event. The two centers continue to work closely, and 2 Bulgarian researchers have internships at DTCC, and joint research publications are in preparation. So this brings us up to date and to today's event, the first GATE Annual Forum. where again researchers from both GATE and DTCC are taking part. Shortly, we'll hear from Anders Log from Chalmers. He's the director of the Digital Twin Cities Centre. And we'll also hear from Desislava Petrova Antonova, who is leading the Data Management Research Unit and Future Cities Application Theme at the GATE Institute. We'll also hear from two Bulgarian researchers who are experts in the digital cities field, Sisi Zlatanova from the University of New South Wales and Mila Kueva from the University of Twente. But first to our keynote speaker. Helsinki has been at the forefront of digital twin cities for many years, and Jarmo Suomisto has worked with 3D and geographic information systems in building design and in city planning for over 25 years. He's the manager of Helsinki 3D Plus, leading the development of the award-winning Helsinki Digital Twin City, and is responsible for creating, maintaining, and delivering virtual models over the whole city. Jarmo was a keynote speaker at the Chalmers Initiative seminar on virtual cities back in April of 2018, and it's my pleasure to welcome him to the GATE Forum today. So Jarmo, please share your presentation with us.
Thank you, Graham, and hi all, and greetings from Helsinki. And thank you for invitation for this panel. Yes, cities are for the people, and cities are very practical. Cities use technology and innovations to create good, happy life to the people in a sustainable environment. As a city servant, I look technology from practical view. And as a former city planning architect, I'm certainly interested in digital tools in creating more lovely and functional cities. We have a 3-person city model team in Helsinki Mayor's office in Strategies Division. Together, our small team has almost 70 years of experience of working with 3D. So we are very realistic with city models. For us, 3D is far beyond eye candy and virtual fun. City models and virtual cities are not a new innovation. 35 years ago, it was like this. Hidden line renderings were then super cool new technology. First whole city model was made in Helsinki in year 2002. It was a LOD1 generated with CAD software. And first use case was showing the new master plan as a texture of a terrain model. Yes, and this is how the city model looks in recent experiments. A lot of development is done and happened in last 35 years. But still, I think city digital twins are in early stages of use case development. Situation is about the same that we had with internet in 1990s, and think what is internet today. Some grand progress can be reasonably expected with urban digital twins. And I think this decade, 2020s, is the obvious breakthrough era. Well, it all begins with data. The availability of the data is the fuel, and data quality or lack of the quality determines a lot of the outcome. Helsinki wants its urban data to be as open as possible. Good quality, secure, and open, accessible, versatile data means usable data. Helsinki data strategy has 4 main goals. First, proactive and personal services on people's terms. Secondly, data-driven decision-making means better decisions and outcomes also in the physical world. Third one, optimization and control of the city's operations and resources. And last, city is an open development platform by sharing data for public common good. There are several types of city models: CAD models, semantic models, point cloud models, reality models, game engine models, and also hybrids of the previous. Each type is functional for special use cases. Enriching the 3D model with data and object attributes is one of the key features of digital twin models. In Helsinki, we have 2 city model production lines. Both models cover the whole city and also 300 coastal islands. We see that reality model and CityGML model are not against each other. It's both and. And at this point, we have use cases for both of these models. Differences of visual appearance are not big, though I think reality model looks a little bit better. But without textures, the difference is clear. And the scientific power of semantic model is obvious. Digital twin is very much a way of thinking and acting, combining urban data models to processes and services is doing digitally first. Getting added value of models and interaction between real world and digital world is the digital twin way. At least in cities, I think 35% of the digital twin work is technology and 75% is cultural and social changes. So having the technical core is just the beginning of bigger change. Has this fact been taken into account when shaping the organizations for digitalization? Hardly, at least too much. Helsinki Energy and Climate Atlas is our flagship service to build understanding what is needed to be carbon neutral city by 2035. It is built on semantic city model, and even the service works technically fine on all devices. The ways of getting benefits of service modules takes time and effort. Open data and open standards enable many-sided co-innovation. Projects with universities are valuable for both cities and universities. Also hackathons and developer meetings are part of our active data policy. One fine example of thesis work in cooperation with Stuttgart Technical University is this service platform. Thanks to Open CityGML standard and Helsinki Open Data Policy, this project was possible with Professor Volker Kors and student Maxim Rosknecht. One model of our energy and climate atlas is directly based on this thesis work cooperational project. And yes, we can support city strategy with digital twins. Smart city goals are widely shared, and digital twins are one essential part of operation system behind a smart city. Helsinki city strategy is ambitious enough. By studying the paper, I found easily 129 goals that we can support with digital twins. For our mayor, this was surprising, but nevertheless, it was for us a giant step forward in digital twin work support by the leaders. Those who are more interested in technical specs, modeling processes, and softwares we used, I recommend this report. It is freely downloadable from our website. I'll end my presentation with a video clip, which is an overview of Helsinki city model use cases. And this is the city model made 20 years ago. All manual work, lots of manual work, many nights, wake up and doing this manual city model. And this is our semantic data. Helsinki has 80,000 real buildings, and they have over 1 million semantic surfaces, all validated, good, solid data. And this is our reality model made in 2017. This is the second version, and the third version is coming from oblique images to be taken next spring. So every third year we make a new model. And yes, game engines are very practical. Here we raised sea level 10 meters over Helsinki. And when our mayor saw this, he was taking it very positively, saying that Helsinki is such a pretty city with water, even prettier than Venice. Okay, that's really positive thinking. And then with game engines more, there's a Finnish company called Umbra, and it's streaming Helsinki city model to Unity developers. So if you use Unity application with a smartphone or tablet, you get the city model background from this Umbra service. They have also an application that you can download there your own materials to make super accurate Unity models for your development. And this is one use cases of the Unity game engine. And this is urban lighting design over that square. The background is Helsinki city model, white building in Unity, and lights are designed in Unity. This could be done in one day, not 1 week or 1 month. It's one day. So you get more in such time. And of course, city models can be also scale models. This is a 100-year scale model from Helsinki, and we made a reality model over it and put it on our service in real-world coordinates. And also project presentations can be done easily. This was made in one day in a web service platform to build the understanding of the huge underground tunnel project, which is not to be realized in Helsinki. And then a little bit of Helsinki Energy and IMAC Lab, because it has a lot of building data, building renovation data, also building years, materials, energy consumption, and such things. It's also now in English in the main titles, so it's not only in Finnish, so you can use it. And also it has the main energy of heating of buildings, and you see in the small house areas it's very varied, and there are also buildings with coal heating. And yes, also a solar potential service, 1 million surfaces. Click any surface there, works on your smartphone, and you get the solar energy radiation potential of that surface like that. This is a co-operational project with Technical University of Munich with Professor Thomas Kolbe. and this has been a wonderful and great success for us. This is for the private house owners. This is for the companies selling the solar panels and the equipment there, and like that. It has also radiation for the walls, and if, of course, if you have windows, you must take the window surface out of the area. And in smart city development, we have also portals over the smart Kalasatama area. This is for the residential people or whoever is interested of the development in Kalasatama area. It has also the projects and buildings to build there, and it has also links to the smart city projects there. And last, I think that we have advanced wind flow simulations in Finland. In Helsinki, I think there's a little bit boom about high-rise buildings, and the wind is then very essential thing to be analyzed before the building in the design phase. Like this. And yeah, one more wind coming from that. Like this. And then last, we have a 2-year cooperational funding from City of Helsinki with Aalto University to develop new technologies and getting more benefits from city models. This is made in Unreal Engine with 6K drone background Helsinki city model, and the more accurate model made from the drone flight. And here you have links to our services, and thank you from my side.
Thank you very much, Jarmo, for that inspiring presentation. Some wonderful work there. I was struck when you opened by saying cities are for the people, and then I felt through the rest of the presentation, it was very clear that digital twin cities are also very much for the people. And I'm sure this is something that we can come back to later on in the discussion. So I think we'll move on now to Anders Log, who is the director of the Digital Twin Cities Center in Gothenburg. And Anders, if you can share your presentation with us, please. And I'll pass over to you. Thank you.
I'm waiting for my presentation to. Can you see me fine now?
We see you perfectly now. Yes.
Okay. So, and you see my slides as well, I hope.
Yes, indeed. Yes.
Thank you very much. So I will talk about the Digital Twin Cities Center, just a quick 5-minute introduction. So this is a new center in Gothenburg, financed by the Swedish Vinnova agency, devoted to the study of digital twin cities. And this is a quite large consortium consisting of partners from academia, industry, and the public sector. And it's mostly a Swedish center with one notable exception, which is Sofia University and the Gate Institute, who are one of our main or only international partner, even if some of these companies are indeed international. So Gate are part of our center, and we're very happy to have them as partners. So I think I will just say a couple of things in this very short presentation. I would say something about what is a digital twin, the definition we are working with, and then quickly show a couple of images from current and ongoing projects at the city center. So what is a digital twin? Well, you can find many different and competing definitions, but the one that we are working with is the following, that digital twins of cities are integrated and interactive, multi-purpose, multimodal, multi-physics, multi-scale simulations of buildings, cities, or regions that use the best available physical data and models, as well as real-time sensor data to mirror the physical city. So it's a lot of multi in here, so multimodal, multi-purpose, multi-physics. So it's something that should be able to be used for many different purposes. And the challenge then is rather to combine all these different models and use cases into a common platform or an ecosystem of tools that can be used, for example, by city planners. So a couple of things that we have been working on. Spatial decision support tools is one part of our project, or one project in our center. wind simulation for urban comfort, 3D prototyping for large projects. This is from a large railway project in Sweden that we are working on prototyping. Interactive web applications, making this able to run on the web browser, oralization and noise modeling, scientific visualization in Unreal Engine. So one of the challenges here is to combine 3D city modeling and visualization with visualization of scientific data, which is something that is usually not present in the game engines. Simulation and combining simulation and IoT data in good user interfaces. This is a part of Gothenburg, and this part is then automatically generated from raw data from the Swedish cadastre. So we emphasize that we want to generate data. We don't do a lot of scanning, that's done by the agency, but from that scanning, from that raw data, I want to be able to automatically create the 3D models, feed them into simulation engines, and then present the result in an interactive environment. And we do that mostly through game engines like Unreal Engine. Here is a wind simulation over the Chalmers campus. So this is the entrance to our campus. Here is a visualization of the northern campus of Chalmers, the same environment by night. And finally, the entrance to the Chalmers campus. So it was a quick overview of some things that we are doing, but we emphasize that we work with our starting point is real world use cases, and want to combine this with scientific simulation, scientific visualization, and then making these tools available as open source tools to the general public and to our partners. So thank you.
Thank you, Anders. We'll move on next to Desi, who is at the Gate Institute, where she is leading the research unit in data management, and also is leading the Future Cities strategic application theme there. So Desi, please share your presentation with us, and I'll pass over to you now.
Do you see it now?
We see the presentation, and now it's full screen. Thank you.
Okay, thank you, Graham. Hello, everybody. I'm very excited to be here in this panel with these people who inspired me. So you know how the city digital twin was born in Sofia, but why we decided to implement it. In one sentence, the digital twin allows us to understand the city, to know what was happened, what is happening now, and what will happen tomorrow. The last picture here is taken from our competition for pupils during the European Researchers' Night this year. The theme was how the city digital twin looks like. So you could see the city digital twin through the children's eyes. What are our objectives within the GATE City Digital Twin pilot project? We aim to develop a digital twin platform for design, exploration, and experimentation of urban environment and processes. It will be used as a tool for stakeholders' engagement, cooperation, and citizen dialogue. Our challenges and related objectives are to produce a high-quality 3D city model of Sofia, starting from part of it by applying the concept of the digital twin, to semantically enrich the model through sharing it with GATE stakeholders, to further develop the model as a simulation, analytical, and visualization tool by applying the basic idea of the digital twin, design, test, and build first digitally, and finally to promote the exploitation of the digital twins in city processes and service production. How our research work is split. The digital twin platform is like a light bulb. The electricity comes from the data management and integration research. Next, the analysis and simulation are like a heating wire. And finally, data insight and visualization research delivers the light. Where we are now, we've started to develop a 3D model of district Wozenets of Sofia. This is localized on a hill south of downtown and extends to the northern foothill of Vituša Mountain. It covers an area of 9.24 square kilometers. Two small rivers flow through the territory, and almost 30% of the area is covered by forests. That is why Wozenet is called the greenest area of Sofia city. In the context of 3D modeling, we've created the first CityGML compliant model of the district, covering the buildings in level of detail 1 and the relief, including terrain intersection. The model is hosted on a Cesium Ion platform. It is a cloud-based infrastructure to host massive and complex geospatial datasets. A web application for visualization of the 3D model is developed using Cesium.js. Although Wozenets is the greenest part of Sofia, a lot of problems arise due to construction of new buildings, which motivate us to implement a use case related to urban planning. The main idea behind it is to develop a tool for parametric urban design in collaboration with Sofia Plan. The tool will support urban planning based on preliminary defined neighborhood indicators related to population, green areas, transport, connectivity, etc. Part of urban planning use case is detection of changes in urban environment based on point cloud data and satellite images. Our second use case includes analysis and simulation of air quality, focusing on pollution dispersion depending on the wind direction and velocity, as well as geometry of the buildings. In collaboration with researchers from Chalmers, the wind flow in urban environment is explored, applying computational fluid dynamics. Here you see the results from the simulation of the wind flow around one of the highest buildings in district Wozenet. This is actually Hotel Marineo. The wind velocity is 2 meters per second from south to north. So the air pollution can be visualized and traced in a similar way. Our third use case is based on the analysis of the solar potential of the building's roofs using point cloud data. The 3D model will be further developed in level of detail 2, where the buildings have differentiated roof structures. Currently, we are working on developing of deep learning algorithm for modeling of roof shapes. And finally, I'd like to thank each one of my team for being enthusiastic, patient, and focusing on the goal that mattered the most. I'm glad that we make such a good team that motivates me and pushes me in achieving the final success of the pilot project. So this was from me.
Thank you very much, Des. Thank you. That's an excellent overview of the situation in Sofia. Thank you for that. So next I'd like to invite Sisi Zlatanova to share her presentation with us. Sisi is professor at the University of New South Wales in Australia, where she...
Thank you very much.
You're there now, very good. So you have a presentation to share with us?
Yes, I have. I hope you see the slides.
We see it very well. And if you make it full screen, that would be perfect.
Yeah, exactly.
Thank you.
Now
in your own time, please.
Right. Okay, first of all, I would like to thank very much to GATE project and specifically the Desislava and Silvia for inviting me at this panel and this event. It's really very exciting to be here. I'm working quite a long time already on 3D modeling. And when I came here in Australia 3 years ago, actually we started really concentrating on digital twin. And I very much agree with what Andres mentioned about digital twin. There are many different definitions, concepts, understandings, but our idea about digital twin is that it is really multi-dimensional and multi-purpose model, virtual model of the real environment, which is supposed to help in analysis and simulation of all kind of phenomena. In the digital twin can be of different size, could be for a whole city, but could be also only for a bridge or for a building. And this depends very much on what is the purpose for which the digital twin is created. And here I wanted to show to you our voyage through developing a digital twin for our campus. It's a relatively small area. It's not a city. It's compatible with a neighborhood. But actually, you probably know in university campuses, so many things are happening. There are so many departments that are busy and taking care of different aspects of the campus. And in our campus, we had 7 departments, and all of them, they had different systems, type of data, different dimensions, accuracy of data. So actually, these systems could not talk to each other. And although there were so many people involved in the management of the campus, sometimes there were very funny and sometimes funny fun, sometimes unpleasant happenings within the campus just because of not knowing what is happening. Okay, so also the software packages, I have them here. You see all kind of different software packages. So when we started working on it, the idea was to create a 3-dimensional campus, model of the campus, which can comply with all the necessary tasks that estate management need to perform. And this includes outdoor, indoor, and underground. Actually, in this project, we didn't consider anything related to underground, and we consider only indoor and outdoor. Okay, so the first thing what we wanted to do is exactly to use open standards and try to map all the concepts which were in the different data and the different systems to open standards. So we selected IFC and CityGML, and we made a subset of all the data sets and all the features and concepts that we had in the data set. And we try to match all these concepts to CityGML and IFC concepts. All the data that we had were pre-processed because also we had to create a lot of the 3D models. Everything was mapped to a common spatial schema. And this common spatial schema we implemented in PostSQL. Actually, the facility management was not that happy with the open source database management system, so they prefer to have something which is commercially supported. But the issue is not about what kind of database management system or cloud you're going to use. The point is exactly about creating the common spatial schema that everybody knows what is happening and what is the purpose of it. And with this common spatial schema, we also try to link the different features in such a way to establish as much as more possible information within the database. And what we also want to demonstrate is that when you have such a schema, common schema, you can make access to it from different front ends. Could be from GIS packages, could be from virtual environments and CAD packages, BIM packages, doesn't matter. So this is very simplified schema of what we implemented, because not everything that we develop we managed to implement. When we had everything in organized according to a common schema, we kept query. And I must say that we had for one feature in our campus different geometric representations. So we had BIM models, we had simple extruded 3D buildings, We have also more elaborated 3D buildings with roofs and structures on the roof. So we had all these organized very linked to each other in the database management system. And this was made with exactly the purpose to be able to use the different representations for different purposes. So we had data from energy consumptions for the building, and these data were per building. We had also data for air quality within some of the buildings, and these air quality data were per room. And I'll show you to you. I hope this one. Okay, let me go out from here. I just want to show to you a short video. Okay, let me escape from here. Close this one. I lost my browser. Sorry about it. Okay, and here is the video. It's available on our website. So the information from the database was also streamed to Cesium. And on this video exactly is visualized that with different geometries you can use for different applications and different simulations. So this is for a level of detail 1 buildings are for simulation of the energy consumption through the year. And here at the end of the video, we have one of the buildings, which this is the building, which has sensors inside the rooms, and for visualizing and analyzing the air quality, actually the BIM model is used. And these transparent boxes that are visible here, these are the IFC spaces from IFC model. And depending on the quality, the measurements of the air quality sensors, this animation represents what is the, actually the quality. We had data about the air quality only for 1 month, so actually this was not that much. But again, it gives the idea of what is happening. So with this, I would like to finish just to show an example of digital twin for a small area, and that again is supposed to serve specific task for the estate management of the campus. Okay, thank you.
Thank you very much, Sissi. That's fascinating work. We'll move on next to Mila Cueva, an assistant professor at the University of Twente. So Mila, you please can share your presentation with us. So I think we have your slides there.
Yeah. Do you see me?
Yes, we don't see you, but we have the slides.
Okay.
But you may want to make the slides larger for us, please.
Yes. Now do you see me?
I can see you now, yes.
Yeah, thank you. Okay. I also would like to thank for inviting me. My name is Mila Cueva, and I'm working as assistant professor in University of Twente in the Faculty of Geoinformation and Earth Observation. And today I will show you a little bit on my experience in artificial intelligence and digital twins. So let me start first with the fact that the name of our research group is called PLUS. So we are focused on people, land, and urban system. We are focused on developing innovative technological solutions for land tenure security, urban processes and patterns, and the interaction in between. I would like to start with one example of a project which is called Eats for Land. It's a big project, Horizon 2020. The aim of this project was to create innovative tools to make land rights mapping faster, cheaper, and easier, and more responsible. Here we implemented an AI or machine learning algorithms, and we were motivated basically from the fact that 70% of the land rights are not recorded. If you want more information, you can look at the website on the end of the slide. Here I would like to show you an application, one of the geospatial technologies that we developed within this project. It's a method based on machine learning for automatic extractions of pictures from remote sensing data. In our case, the features were cadastral boundaries and building outlines. The tool that we developed was integrating in QGIS, and it was applying. It can be applied on satellite images, aerial images, and UAV data. We also developed some functionalities for editing and on the extracted data. As a result, as you can see on the slide, compared to manual delineation, the number of clicks per 100 meter was reduced to 86%. So this was kind of an achievement that we had applying artificial intelligence for land administration. And I believe that this can be applied also on a global scale, on a city scale. You can see here some references on the from the project if you're interested to look at. I mentioned this example, which is a possible example of application of artificial intelligence using geospatial data, because AI is very powerful and it can be used for automation, also for prediction, and it can be useful also for digital twins on a city level. And now talking about digital twins, why do we need them? In the past decades, there was really a rapid growth in the increasing urbanization, and urban built environment is changing not only horizontally, but also vertically. So we need to have a very good representation of our cities to make fast and efficient decisions on the level of cities. So in the next slides, I will show you some examples of our work on digital twins or 3D city modeling, as we are used to say it. This was a project which was about subsurface and surface integration in Rotterdam. It aimed to enhance multidisciplinary communication between the urban planners and subsurface specialists. Before the development, we assessed the needs, and after that, we demonstrated some 3D analysis that can be performed on a city level. You can see on the video, it was about soil pollution estimation, water flooding, solar potential, and so on. Another project that I want to drive your attention was related with 3D and 4D valuation. It was in China, where we have buildings of 40, 50 stores. And the aim was to examine the factors that should be taken into account for price formation of the properties in a vertical dimension, and how these prices may change in time. So after, again, interviews with citizens and focus group discussions with experts in China, we demonstrated the importance of the visualization and analysis of data in 3D on a city level. Again, you can see some references if you're interested more. Another research which was done in Netherlands, it was related with the 3D for solar photovoltaic potential. Here, we focused on integration of laser scanning data and point clouds derived from dense image matching. Here is the moment to mention that dealing with point cloud data means dealing with terabytes of data. So after the data integration, we aimed to visualize the solar potential of the buildings. It's a research that we continue now, and we plan to involve more deep learning and machine learning algorithms for this. And since we have only 5 minutes, I would like to conclude with another research, which was done on a city level, and it was for Kenya. And there we aim to help for public participation in decision-making process. It's an example for development or redesign of a new area in a city. So we proved that 3D and web-based visualization can contribute to better understanding for the whole environment, and it can help for citizens, but also to experts and can help in general for e-participation. So these are the examples I wanted to share with you. I'm open for questions and discussion. Thank you very much.
Thank you, Mila. Thank you for that. So I think now we can perhaps bring the whole group together, the whole panel together, and we can discuss some issues among us. And I'd like to start by asking each of you for a short answer, ideally just a one-sentence answer, to the question, why should a city have a digital twin? So perhaps, Jermo, I can start with you on this.
Okay, yes. Of course, it's obvious that the global urban challenge is a huge thing, and somehow to manage the in the city level all the challenges, air quality, life quality, social things, healthcare, whatever. Digital twins is an essential tool for that. And I'm very happy that we have a global standard like CityGML. It enables the global cooperation with cities. And I think the whole 3D community, global 3D community, is very open to share experience, because we are not competing with each other. We are just doing the same work for the global common good.
Thank you. And perhaps, Anders, I can turn to you next. The same question. Why should a city have a digital twin?
Well, my answer will be that we are constantly striving to make our society better by the use of technology. And one of the main technologies for doing that is digitalization. And the way to digitalize something is to build a digital twin, whether it's a city or an airplane or a car or whatever we build. So it's essential. The digital twin is the starting point for digitalizing something and making it better.
Thanks, Anders. And Desi, why should Sophia have a digital twin?
Just to add something to Anders, because the digital twin allows us to get the value of the data in order to make better life for citizens.
Thank you. And Sissi?
My question will be very short. Digital twin allows us to simulate and analyze things that otherwise, in reality, probably we cannot perform that well.
Thanks. Is it like the emphasis there
we take information from the real world, put it in the virtual digital twin, and we try to understand what is going on.
Yes. I picked up from the answer there the word simulation, that it's not just a matter of visualizing the city, but it's really having it in a computational form where we can use it.
Yeah.
That's a very nice point. And Mila, to you, why should a city have a digital twin?
Most was said, but I would just add that it can serve multiple purposes and multiple users. So used for many applications, and it can also combine different views of a government, institutional, and citizen view into one direction for one goal.
Okay, thanks for that. I noticed in Desi's presentation at the start, we had some pictures of Sophia many years ago. And I just wonder whether either you, Desi, or any of the other panelists have any comments on where historical data can fit in with digital twins, cultural information. Do any of you have any experience or remarks on dealing with different versions of a city as it changes through time? Perhaps Anders, I know that there's been some work with historical versions of Gothenburg.
Yeah, I mean, the city of Gothenburg, they are part of our center, and they have done, I mean, even before the center started, they did impressive work on digitalizing the 16th century or 17th century Gothenburg. I mean, when it was just created. So they went to historical records and they made a very impressive, I think you can find it online, a nice visualization film where you can experience really Gothenburg in the 17th century. And it's playing at museums in the city. So that's an example of where you can go to the original data and then recreate that. Of course, that was made, I mean, it was a large undertaking to do that. It was manual work, making this movie, creating these environments, but it's a nice example of where you can go back in time. In the center, we are working with, when we want to be able to do that, I mean, with present data, to have this digital twin where you can have like a slider where you can sort of drag the city, the timeline back and forth, even into the future. That's an important thing too. And of course, that then connects to the simulation aspect of the city.
Thanks, Anders.
Yeah, I think the same. It's I also did when I was at Delft University of Technology. I was working there for almost 30 years. We did with students reconstruction of old Delft, and actually, again, it's very important exercise, because after that you can analyze a lot of things. You can analyze why the buildings or the roads or the streets in the city has changed as they changed through the years, and what are the new developments and why the old buildings or old houses disappeared. But actually this was not my interest that time. Now when the point is about digital twin, it's a good question to think of whether these representations of the city with the time, really from centuries ago, should be also considered as a part of the digital twin. It's going to provide a lot of information for analysis.
Thank you.
I believe.
Thanks. I'm aware of the time, and we are approaching the end of our hour, but I would like to get thoughts from each of you on the opportunities and the challenges of now connecting with external stakeholders. This is something I know that we've been thinking about in Gothenburg, and we have, and I'm sure Anders can describe this. Perhaps we can start with you, Anders. Your thoughts, your reflections on the opportunities for engagement with external stakeholders, and what are the incentives for external stakeholders to become involved in a digital twin city project?
I might try to say something about the challenges, because I mean those are more obvious when we talk about the work in the center. One of the challenges is that, of course, all these partners that we have, they are already working in some sense with digital twins, and they are using existing processes and tool sets, some of them commercial, some of them in-house. And then the challenge might be to, I mean, if we are going to work together with those stakeholders, with new data, with existing data, with new projects, how then do the tools and methods that we develop, how does that integrate with and connect to existing practices and tools? It might be that an organization, they have built up some practices with some in-house software, for example. If we are to develop new software, new methods, how can we then integrate that with the existing tool set that I have? And there might be many challenges both legal challenges, who has the right to the software, and also practical. I mean, they have developed this over a long time and invested a lot of effort into this. So it's sometimes not a technological challenge, but a political challenge where there are existing practices, and how can you then meet, because you have already invested in your current tool sets.
Perhaps Jarmo, can you comment on this? And I'm also interested in any challenges in getting external stakeholders to share data and attitudes towards data sharing.
Yes, our city model data has been completely open data for 4 years. And yes, the reality model is the most popular, and something with city GML and some converted things. It's the social part. It's the big part. how to change the way of working and thinking. It starts very slowly. First 2 years, hardly anything. Now we get good initiatives and project proposals and getting those. But I think cities must be active in their open data policy, organize hackathons, developer clubs, and such things. That's the only way. Also, our smart city project like Kalasatama. Now we have the smart 5 districts in the city called smart city project that we try different things with different stakeholders, and so we try to build the social connection also with the technology and then get the benefits. But it's a long-term commitment.
Yes, thank you for that. Mila, on the same point, collaboration.
It's a very good point. I would like to share that my experience in collaboration was based on this project that I mentioned. It's a little bit more AI oriented, but there we had 8 consortium partners. We were the leading university. There was Europe and Africa involved, and different stakeholders, academia and private. So in the last 4 years, it was quite challenging for me to lead this big consortium, but we brought it to a success, which I'm quite happy. And now I'm trying to have a continuation of this project. There were challenges in terms of technological differences, for example, between European and African countries. There were political challenges, but we managed to overcome them. If the partners are dedicated, if you manage to lead to a common aim, the whole consortium, they can be overcome, let's say, the challenges. Yeah.
Thanks for that. Sissy, can you comment on this from your perspective?
To me, there are quite a lot of challenges still in high resolution data. And when I say high resolution, I mean indoor environment. So technically, from a technical point of view, how to integrate indoor models with outdoor models or underground models is still quite an issue. And when you go to a higher details, and especially to BIM models, then the computational complexity increases a lot. So here I see quite a lot of technical issues that we have to work towards. The other issue is on the legal, organizational aspect, sharing the data. So many of these high resolution and high detail data, they're private. So it's very difficult to obtain BIM models. For specific purposes, you can obtain them, but you cannot share them. So something has to be done also there. Actually, for me, the problem at the moment is exactly this BIM models and the resolution of the BIM models, how we can include them in our 3D digital twins.
Thank you. And turning to you now, Desi, how will the Gate Institute be cooperating and collaborating with external partners in this area?
So first, we have a strong partnership with Chalmers University and CIT. Gate Institute is a research partner in Digital Twin City Center. Thus, the building of a digital twin of Sofia goes hand in hand with the building of a digital twin of Gothenburg. Next, we have a great connection with leading researchers and experts such as Jarmo, Sisi, and Mila, who are now with us. This year, Gate Institute signed an agreement with Sofia Municipality for collaboration and data sharing. Joint activities have started with Sofia Plan. Sofia Plan supports us with cadastral data, and more than 20 data sets are available now for our researchers. The support from the business is another key factor, not only in terms of data collection, but in provision of technology solutions, which could be part of the digital twin platform, as well as from our Gate Living City Lab. In such context, we've received our first support from the business thanks to the mixed robotics. The 3D semantic model will be developed on a higher level of detail using point cloud data. So don't miss the mixed robotics video presentation after this panel.
Okay, thank you for that. So I think time is up for us, so we should leave things there. I'd like to thank you all for your participation in the session this morning, and we'll pass back to Sylvia. Thank you.
Yeah. Thank you very much, Graham, for this interesting panel, and we brought experience from many different places. We have from Australia, from some experience from Africa through our Bulgarian colleagues, part of this Bulgarian diaspora, who will join us in and transfer knowledge and participate in our future activities. Thanks to Jarmo, they're the best in Europe, so we are learning from them, and it's good that they're open and they're sharing data experience and everything. So, and we are partners with the Digital Twin City Center, and we'll continue working on this. Thank you very much for your time and for interesting talk.
Yes, thank you. Bye-bye.
Thank you.
Bye-bye.
And now we are moving to the next videos. The first video will be for this European Center of Excellence on Big Data, CIDR, who is in Dublin in Ireland, and they're very well working with and supporting industry. They're developing tools and support the needs. So please see what kind of services they're offering, and it's very interesting. And also, Desi mentioned about mixed robotics, which we're cooperating in the city, the very innovative startup company in Bulgaria. And I know we will hear for them in the future more. And after that, it will be a lunch break, and exactly 2 o'clock we are continuing in our third panel on digital health.
Hi everyone, my name is Yassine Jelassi. I'm the commercialization manager for the CIDR Center. CIDR is the National Center for Applied AI in Ireland. We are funded by Enterprise Ireland and IDA, which are part of the Minister of Business, Enterprise and Innovation. We are also part of the largest university in Ireland, which is UCD. So CIDR is also EU Digital Innovation Hub for AI in Ireland. So there is 30 hubs across Europe, and we are the one for Ireland. We have been also awarded the iSpace Gold Award recently from the Big Data Value Forum, which shows the important and key role that CIDR is playing in the Irish and European AI ecosystem. So CIDR is what we call a market-led technology center. So we are a non-profit organization, and our main objective is actually to develop and deploy AI solution in order to deliver value and increase the competitive advantage of Irish company and European company as well. So we have around 90 industry members. from all sorts of sectors, from agriculture, renewable energy, financial services, insurance, banks, and so on. And our main objective is actually to help all those companies to be more competitive nationally and globally. So CIDR is bridging the gap between the academic world and the commercial world. So we sit between TRL 3 and TRL 9, so we try to be as close as possible from the market. And basically, we leverage the academic excellence in order to develop a ready-to-use commercial solution for our clients, which can bring value to them and for their own customer as well. So CIDR Center offer, let's say, a wide range of services. The first one is advisory. So basically, the CIDR Center can be considered also as, let's say, AI consultancy firm. We help company to, let's say, set an AI strategy roadmap or a data architecture strategy roadmap in order to support their AI initiatives. So we help them to choose the technology, to choose which service is best fit for their own needs. We also engage in one-on-one basis with our client, and we deliver to them bespoke solution. And this is the largest part of our activity. So basically, the way it works is that, let's say, we try to organize a workshop with our clients, and through those workshops, we try to understand their needs and scope a project and scope what will be the right technology to help them solve their challenges. And at the same time, company might be able to leverage some of the national funding and de-risk those projects. And this is like a great opportunity for them to let's say, embrace AI technology, test them before actually investing too much money on projects. We also run what we call the demonstrator program, and this is very unique to the CIDR Center. So basically, every 6 months, we ask our NGC members to propose ideas, and all our NGC members vote for the ideas that they want to see going forward, and then we'll develop those. So those ideas actually are challenges that might be solved with AI. So basically, we develop solution to solve those AI solution to solve those challenges, and those solutions will later on, once they develop it, will be available to try from our NGC members at no cost. And this is also a way to inject AI DNA in the ecosystem. We also run business seminars to all sorts of audiences. We have weekly tech talk. We run also a few webinars on important EU funding calls. We collaborate with the whole, let's say, SME and startup and multinational companies ecosystem in Ireland, and we engage in a lot of European and national consortium to tackle big challenges and deliver large-scale projects. So sometimes we also try to build those consortium to leverage our NVC members in order to create a value chain of expertise. As I said, we also run a series of workshops. We run an average of 3 or 4 workshops per week, and those are a good opportunity to interact with our client and members and see what are the challenges that they're facing and how AI can help there. We also run a series of training, and this targeted to also all sorts of audiences, from AI expert to novice AI people. We also have the apprenticeship program. So basically, we place data scientist graduates in companies. So those graduates are actually employee of CIDR, and get training from CIDR, and we place them to work on live project for companies. We also guide our clients along their AI maturity journey. So basically, we can, let's say, once we meet with the customer or the client, we can assess their AI maturity, and let's say from a scale from 1 to 5, assess where they stand in that scale, and then from there we can give them advice on how to go to the next level. CIDR is also an incubator, so we have a spin-off spin-off program, and basically there is 5 companies being incubated in CIDR right now. They leverage our IP, and then once they spin out, then they will be they are able to spin out as a standalone company. And we engage in, as I said, in a lot of EU funding. So we do B2B and EU brokerage, and we offer to our industry members computation and storage infrastructure. So next month we will be receiving a supercomputer from Dell, which will be available for our member companies to use in case they need some computation power. So thank you very much, and please feel free to contact Edward, who's director of CIDR Center, or myself in case you want any more details about CIDR. Thank you.
What is a smart city? Governments nowadays are increasingly aiming towards incorporating smart city solutions into everyday city life. Smart city management involves utilising data collected from various sources, such as drones, remote sensors and cameras, satellites, and citizens. The data is then processed, analysed, and applied to city-wide operations, including traffic and public transport management, air pollution monitoring and waste management, urban planning, and public infrastructure management. A smart city allows efficient, real-time responses to issues like traffic jams, public safety violations, infrastructure maintenance, and more. At MYX, we've developed a proprietary platform that enables the creation of realistic digital replicas of buildings, infrastructure, or even entire cities called digital twins, accessible to individual citizens, government officials, and businesses. We've worked on developing a number of specific solutions that address pressing questions in the area of infrastructure maintenance, air pollution management, urban planning, and transportation. A digital twin can provide a way for citizens to effortlessly participate in the improvement of the city. Reporting a problem, such as a damaged road or a broken traffic light, will become much more efficient and accessible to the public. Relevant authorities would then be able to use the information to better monitor and maintain the city. Being able to create photorealistic digital representations of critical infrastructure such as power lines, antennas, or roads in real life is critical to active prevention. Our advanced algorithms can detect and report on anomalies versus predefined physical parameters such as tilt, bent or pinched cabling, rust detection, or general geospatial positioning. As proven by cities like Singapore and Dubai, having a digital twin shows major improvement in urban development and preservation. Digital twins allow for a realistic architectural modelling and visualizations that can be put to public discussions prior to approval. The technology can be applied to construction surveillance and control in order to ensure compliance to building permits. Regular data updates would allow keeping track of changes in green areas and bodies of water throughout time. Furthermore, trees can have individual digital passports with measurements and other information. Our platform can make air and noise pollution tracking more precise, helping find ways to reduce it. The digital twin is also capable of showing areas with the most solar potential for possible solar panel installations. Sub-millimeter resolutions allow close object examination, providing a way to remotely oversee conditions of cultural heritage sites. With access to this new information, the effort to preserve the original state and extend the lifespan of monuments, parks and museums could be executed more accurately and efficiently than ever. With the collected data, many positive changes can be made in the public transportation system. Not only will the citizens be notified about road accidents and delays, but government officials will have real-time access to digital replicas of any public transport infrastructure, such as bus stops and tramway tracks. With this information, authorities would be able to remotely monitor crowds, keep track of potential or existing roadblocks, and manage public transport in real time. They'd also be able to plan the expansion of the public transport network and provide adequate response for possible emergencies. The practical applications that digital twins can offer businesses in nearly all industries are endless. Applying this new technology would result in a more effective maintenance scheduling, significant downtime reduction, and minimised costs. Our goal is to create an accessible base platform available to anyone on any device, smartphone, tablet, or laptop. Making Sofia a smart city would be an elegant and holistic, yet cost and time effective solution to the ever-increasing demands of the big city. It will provide a better understanding of current and potential problems, and easier and more efficient solutions than ever before. Our platform is a tool to enable an interactive citywide system, creating opportunities for a better city life, a step towards the future.
Welcome back to GATE Big Data and AI Forum. This morning we had a lively opening session with high-level officials. Then we have two panels. The first one was Big Data and AI, where we discussed the sharing data, the talent, the new skills the data science engineers need, and very interesting discussion. The next panel was on Digital Twin City, where our partners and collaborators shared experience about how some useful use cases and how they did this in different parts of the world. Now we are moving to the next panel, which is on digital health. And I would like to introduce the moderator of the panel, Dejan Paležev, who is from GATE Institute, leading this direction, future digital health. And he has a Master Science from Mathematics from Sofia University, then PhD in Yale. And 5 years ago, he returned in Bulgaria and was leading a data science team in one of our big organizations. And just last year, he joined GATE. And now he'll moderate such interesting panel. Dejan, the floor is yours.
Thank you, Professor Ilieva. So, a couple of words about this session. The goal is to discuss different elements of the process of gaining insight and applying that insight in the domain of digital health. Particularly in this year, there is no need to explain the importance of the digital health and the healthcare domains to people. And obviously, no single organization can contribute alone to the innovation of in this domain. And there are many different organizations of different types that are helping the advances in the health industry and in the digital health. So the goal of today's session is to give you perhaps not an insight, but just a glimpse of the collaboration between the different types of organizations and the different stakeholders that exist in the field. This would be biomedical researchers, hospitals, medical doctors, people with technical skills in data science, biostatistics, bioinformatics, smaller companies, startups, and of course, the industry. And for that, we're going to have participants from different fields that are related to this domain. That includes the ecosystem, of course, industry, academia, healthcare providers. And now, without further ado, let me introduce our keynote speaker, who is Professor Dr. Milan Petković, who is the Vice President of the Big Value Data Association. Professor Petković.
Thank you, Dejan. So thank you for inviting me to give this keynote. Let me also share my screen because I prepared a few slides. I hope you're getting my screen. Yes. Indeed, it's a great pleasure for me to participate in this symposium and talk about opportunities and prospects in digital health, and as well as the importance of data and AI technologies in this transition of the healthcare sector. I'll start with a simple message. Basically, we need data, we need AI algorithms in order to improve our health, and I hope I'll be able to explain this to you in a few slides. First of all, a new era of healthcare is emerging, the era in which people increasingly take ownership of their health and their well-being, supported by industry, supported by healthcare sector, public sector, etc. For Philips, this is Philips is a company with a presence in both the personal health as well as professional healthcare worlds, and this presents a real opportunity to continue what we have been doing for 125 years, which is creating meaningful innovation that improves people's lives. So at Philips, we set to ourselves an ambitious target. We want to improve lives of 2.5 billion people by 2030, and by making the world healthier and more sustainable through innovation. That's our main goal. That's just to give you a bit of a context where I come from and what the view of a company on this space is. Now I'll focus a bit on the first of all, the trends in healthcare, again, to just give you a bit of a bigger context of why we believe that digital innovation in healthcare is so important. There are 4 trends nowadays in healthcare which drive this need for innovation. First, more and more people are suffering from chronic illnesses. Second, we expect from our healthcare systems better healthcare, better patient outcomes, but we also don't want to pay a lot. We want to have this for lower cost. Third, we as citizens, we want to take control of our health as well as healthcare. So if we get ill, we are taking more and more control of that. And finally, healthcare sector is undergoing digital transformation, and that digital transformation results in a lot of data that is created, which also is a big opportunity. So I won't spend a lot of time on first 3 drivers. So just want to give just to make sure that I bring it to your attention that one of 3 of us would get a sort of, cancer, unfortunately. And that cancer is becoming a chronic illness more and more, because it's not, in most of the cases, you need actually to treat these people longer. 1 billion people are estimated to have hypertension, which leads towards cardiovascular chronic diseases. So it's a big group of people that we need to take care of. On the other hand, we are spending a lot of money on healthcare systems. 10% of GDP in European countries is spent on healthcare. With that trend, in 2050, I think we'll be spending 50% if we continue rising the healthcare cost as that goes for a couple of years. So on the other hand, we see, especially now in pandemic, that there is a lot of problems with the healthcare workforce, and we need to help these people so that they can actually do their job properly. As mentioned, many people are looking now into their own health and would like to take control. So that's another trend. But I'll focus mostly on the last factor, which is maybe not so much driving the need for innovation in healthcare, but is actually providing opportunity. And that's this data, because this digital revolution that we had started, that creates a lot of data. And you can think of, lifestyle data created in the lifestyle setting, where we collect a lot of data about activity that we have, or we measure certain vital signs. But then you can also think of a lot of data that is created in the healthcare sector, electronic medical records, etc. So this growth rate of increasing the data in healthcare is 50% annually, which provides a big opportunity. So how quickly is this digital transformation happening in the healthcare sector? So a year ago, we would probably say that can be done faster. But now with COVID, we've seen dramatically that this accelerated actually. COVID brought us a new reality where quickly, we really need to get all this. So we see a lot of people that started actually using this virtual care services. They accepted those things because they are safer. It's much safer to have a consult from a distance if you can solve the problem in that way. And we've seen very much the importance of the sharing of data, which I'll talk about in more detail. This slide depicts the healthcare continuum. It starts with healthy living, it goes to prevention, diagnosis, treatment, home care. If we have relevant data for each of these phases, and if we can put all these data together, that can obviously help us to create new medical knowledge or create insights about the health of the patient. This data will allow also companies like Philips to create innovation, because having access to these data help us to understand and apply AI algorithms to actually address the needs that the customers have, the healthcare providers have, the patients have. So, and then let me talk about some of the challenges and some of the ways forward. We believe that putting data, AI algorithms, and clinical knowledge together, if we put these three together, that we can create actually AI-enabled solutions which can address these needs of the healthcare sector, which can improve the outcomes, patient outcomes, provide lower cost of healthcare, help actually healthcare providers to deal in a much more efficient way with patient and their job, as well as to improve patient experience. And by combining AI algorithms together with clinical knowledge and data, we can ensure that actually these features or functions that we provide to healthcare providers or patients, that they are in the right context, that they understand actually what is the context of the patient, where is the healthcare provider. They can adapt to this context, and they can integrate very well into workflows and address the real need. So let me give you a few examples. How can we turn data, AI, and clinical knowledge into value? And I'll start with a very recent example, focusing mostly on the data part and the pandemic, because this pandemic taught us some very important lessons. First, about the importance of data sharing. And secondly, that still we need actually to make further steps to improve this data sharing in the healthcare sector. There are great examples, and this is one of them, which is from the Netherlands, where Philips, together with the Dutch government, actually created very quickly a national portal to exchange COVID patient data in the Netherlands, because obviously, as in the other countries nowadays is happening, we had to move patients from one hospital to another to make a sort of, to balance the load on hospitals. And then it is very important also, together with the patient, to send the data, not obviously in ambulance, but to ensure that there is an infrastructure that the hospitals can actually share data of these patients and ensure that there is a proper handover of the patient from one hospital to another hospital. There are also very nice initiatives from European Commission, like COVID-19 data platform, Vodan initiative, etc. But still, we are not yet there when it comes to sharing of health data. There are lots more steps to do. There is data sharing across member states in Europe and further on. So, however, maybe it's most interesting to look at the elements where we put together actually the AI algorithms, data, and clinical knowledge. I will just give you one in the next slide, and I brought this slide just to show to you that in Philips we are maintaining a transparency page which lists all AI-enabled propositions. And you can, if you're interested, you can take a look into and read more about those. Today, I'll just mention one, just to give you a feeling what is this about. This example is about detecting early signs of patient deterioration in general care setting. It is a product called IntelliView Guardian software, and it's running into it's actually in a general ward in hospital, and it's meant to it is meant to basically help doctors to identify whether a patient is getting into critical condition. And you might know that in intensive care unit, you will have a lot of vital signs measurements, and then you will have a lot of alarms. If certain vital sign like heart rate or blood pressure goes above certain threshold, then there will be an alarm. This system allows you to actually predict that this will gonna happen. And how does that work? It works based on historical data and the outcomes of the patients. So basically, with a lot of data and good AI algorithms, we are able to create models and predict that in an hour or in 2 hours, that particular patient will actually get to the critical condition and then give time to healthcare providers to basically do an action and ensure that the patient does well. And that obviously in studies, and you can see on this slide, gives lower mortality rates, lower ICU readmissions, which saves a lot of cost, et cetera, et cetera. Then maybe to also bring to your attention a European project that you might have heard of, which is in the data PPP. It's called Big Metalytics. And the goal in that project was basically to bridge the silos between healthcare providers, between hospitals, between health tech industry, between pharma and payers, which are in many cases insurance companies, with the main goal to unlock the value of data that is collected between these silos and demonstrate the benefits of how this data can actually be used to address these challenges of the healthcare systems that I was talking about. So project is finishing in August next year, and is already proud of many achievements along the biggest healthcare challenges, improving patient outcomes, facilitating this unlock of and the value of data, looking at the data quality, improving productivity, etc. So I encourage you to check the project pages and look at it. Finally, I would like to address the biggest challenge with data. I already mentioned the challenges with respect to AI, which for me is to bring basically AI to the next level, to combine data-driven approaches like machine learning, deep learning with knowledge-driven approaches, and by that also broaden the space from narrow AI to more wider AI, and hopefully long-term in the future to general AI. But let me finish by talking a bit about some data challenges. So first of all, in the healthcare space, all of us, I think we all welcome the European Commission initiative to create common European data spaces, because we believe that data sharing provides a really necessary basis to tackle the biggest healthcare challenges we face nowadays. Still, as I already mentioned, there are European action needed actually to ensure cross-border challenges, so that we can share the data cross borders, to also to align all regulation in Europe related to sensitive data like healthcare data, so that we can basically are able to have one single market. The creation of a common European health data space in which health data information is exchanged cross-border, and which enables the participation of all the stakeholders that were mentioned also by Dejan and myself in this ecosystem, I think it's a big priority. So I would like to finish with a few challenges and maybe also some recommendations. So I think first it's very important to unlock the value from data, which is held by public sector. There is a lot of data which is collected in hospitals, by healthcare systems, and ability to harness large volumes of these data and use AI with this data will definitely accelerate innovation in Europe in the healthcare sector. Secondly, I think we should make it easier for individuals like ourselves to share data for public good, health data, donor the data, basically. So I think if we are able to facilitate such a process, that we can also get it going, and obviously by raising awareness of how that will benefit all of us, how that will benefit the society, ourselves, our family members. Thirdly, I think we should prioritize standardization needs, improve data interoperability. And then finally, I think we need to ensure that our organization and infrastructure for data sharing is at the right level. So there are a number of initiatives like Gaia-X that could be instrumental in bringing that process. Also, the European public-private partnerships can play a role, but it's important to address this. Finally, I would like to bring to your attention an upcoming public-private partnership of AI, data, and robotics, which is initiated by Big Data Value Association, Claire, Alice, EuroAI, and EuroRobotics. If you're interested, please join us so that we can successfully shape the future of Europe. Thank you for your attention.
Thank you, Professor Petkovic. If I may ask you just a quick question. Obviously, you have a unique perspective in the field due to your affiliations with the industry, being Philips with the Big Data Value Association, that kind of covers the ecosystem and also in academia, so that you can see the domain from many different points of view. And you already answered part of my question about the challenges, but also I would like to ask you, what do you think was the biggest improvement in collaboration between the different stakeholders over the past several years, or perhaps even this year? You mentioned that many things were accelerated by the pandemic. So yeah, what is going on well, and what has improved the most significantly recently?
Yeah, thank you for your question. Yeah, so I think during last years we identified, actually in many cases, the value that can be created by putting this data together and by having collaborations between different stakeholders in healthcare sector. We've seen in the past, for example, a lot of hesitation between hospitals and insurance companies, so that they don't want to share the data because hospitals are worried that insurance companies will stop funding certain activities they have, etc. So, however, if there is a win-win, and they can actually, in these public-private projects, they can see actually the benefit of sharing certain data, or sharing the data in a way that that you're not disclosing everything, that basically the value can be created for both. And the same is also, I think, that we would need to do with citizens, because we don't want to go in the direction of, that some big maybe companies from the West are doing, that they are in most of the cases actually asking you as a citizen to share the data, otherwise you'll not get the value, and then there is no other choice. But if we raise enough awareness of a win-win situation between patient and as well as the research population and healthcare, as well as industry, that they might be actually willing to share the data. And I think this part we still need to develop further. I think we're already in the industrial sectors already getting connections, and there is more connections between healthcare providers, industry, but with citizens, I think we could still improve, and we can still raise awareness and facilitate this data sharing, so that that basically, all the people in academia that are working, researchers in this sector, can actually get access to more data. And by having access to more data, then they have a chance to improve healthcare by just bringing new innovation in.
Yeah. Thank you. Thank you very much for the insightful presentation and overview of the state of the digital health domain in Europe.
Thank you for inviting, and I wish you a successful panel. Bye.
Okay, so next I will say a couple of words about what we do here at GATE. So, as Professor Ilieva mentioned, we started the unit that does research in the digital health domain several months ago. We are still a small unit, but we are looking to expand. And the overall goal of our activities is to design and apply machine learning and artificial intelligence methods to all sorts of biomedical data and solve the related problems. In addition to machine learning and artificial intelligence, we have an expertise in, let's say, more traditional fields as bioinformatics and biostatistics. Being a big data institute, our main projects are related to a type of data that is really big data, and this is the next generation sequencing. So the next generation technology provides many millions, in some cases hundreds of millions of so-called reads or sequences of DNA or RNA base pairs or nucleotides. And the good thing is that the technology is getting cheaper and cheaper, and that the output is getting larger and larger, so we can gather much more insight with that data. Based on the next generation sequencing data, we have two main projects that we're currently working on. One of them is what we call omics type of analytics on Alzheimer's data. So the purpose of this is to use next generation sequencing data to create segmentation of patients or potential patients, and also to try to predict the decline in the cognitive function of those patients. And again, given our expertise, here we would use various robust artificial intelligence, machine learning and deep learning methods in order to be able to develop those models. And this is a joint work with colleagues from Chalmers and from Yale. You'll see a little bit about that project later on. Also, we're working with colleagues from Stanford on detecting complex structural variation events in several thousand individuals. Also, we are improving one of the existing methods for prediction of particular types of events that is based on machine learning. Also, in addition to these main projects, we do what I call consulting work for other colleagues in academia and also some startups in the industry. We analyze data from apps that collect biomedical data, or also from connected devices. And now let's continue with our panelists. The first one is Dr. Rosen Dimitrov, who is a vice chair of the board of the Digital Health and Innovation Cluster in Bulgaria. And as such, he will tell us a little bit more about the Bulgarian ecosystem that his cluster represents to a major part. Awesome.
Thank you very much, Dan. I have prepared a short presentation just to introduce our organization representing the digital health and innovation ecosystem in Bulgaria. So our cluster organization was created 2 years ago, just after the Bulgarian presidency of the Council of the European Union. And it was inspired by the words of Roberto Viola, representing the European Commission. He was here in Sofia during our presidency, and he participated, he took part at the Digital Assembly. And he said a couple of things that made us think about how we could make things better. So he said that Europe is going for a data-driven healthcare system, which is something very, very different from things that were previously done. And he said also something very important, that this data-driven healthcare should not be some state-controlled enterprise. In fact, he said that it's very difficult now for states and governments to move to this data-driven healthcare. And this could be done only by means of an ecosystem that is open for private entrepreneurs who provide these tools that create value out of the vast technological and data resources. And based on this, 2 years ago, we created the Digital Health and Innovation Cluster Bulgaria with a clear vision that we need a sustainable and effective healthcare system based on data and technology. And the way that we want to achieve this is by means of this ecosystem, by creating an ecosystem, by developing this ecosystem. It sounds like a buzzword, you know, an ecosystem, but we saw that in these 2 years, this could be done. And now you can see that in our organization, we have more than 30 companies and organizations, members of the Digital Health and Innovation Cluster. We have big pharma companies. We have big IT companies like Microsoft, like VMware. We have big Bulgarian IT companies like BGO Software, like Ontotext, for example. We have smaller companies, but very focused on telemedicine, on data, on predictive analytics. Companies focused on electronic health records, on cybersecurity. We have also serialization in production. We have also non-government organization, especially the patient organizations are here, the organizations of physicians and pharmacists. So in fact, we have all these different stakeholders that are part of our ecosystem now. And this is just 2 years later. And now, in the next couple of months, we will have even more companies applying to join our cluster organization. And what do we provide as a cluster organization? We saw that it's very difficult for the companies to enter the healthcare system, especially if they don't have expertise, but they want to change something. So the first thing we provide this is access to up-to-date and timely information, access to business information for them. Also, we provide support and development of their digital solutions they want to provide for the system. We serve as a platform for collaboration, and we provide also mentorship in healthcare and educational system. And in fact, our cluster organization performs the role of an ecosystem orchestrator. And here you can see how it works. We are giving this value proposition for effective and sustainable healthcare system based on data and technology. We work with academia, we work with the university in Sofia and with the second biggest university, which is the one in medical university, which is the one in Plovdiv. And in fact, the ideas come from academia, but we want these ideas to go further, to go to prototypes. And that's why we supported the creation of the pre-acceleration program, which is called Beyond. It was created together with Junior Achievement Bulgaria. And in fact, in this pre-acceleration program, we move the ideas of these young people to prototypes, and some of them move to startups, and these startups enter our ecosystem, they enter our cluster. And what we saw from our European experience, that cluster organizations are widely supported across the European Union in different programs. And we got in touch with other cluster organizations from Austria, Germany, Spain, and we see that this model is working quite well, because cluster organizations are a good way to have all different stakeholders on board, and by different business models to move forward in terms of digital transformation of healthcare. And I will also share with you the main strategic topics that we work on in our cluster. Of course, we start with patient as an active partner, all different solutions for the patient engagement. We move to prevention. In fact, prevention is the main topic and the first starting point. Everything connected with knowledge on time. It was discussed in the first presentation, all that data and how we could create different solutions, predictive solutions on this data. Of course, all these should be done as an ecosystem of services and different components, not to stay in silos, but to work as a common ecosystem. Of course, everything should be done with all cybersecurity standards. And at the end of the day, what we want to achieve from all these different types of digital health solutions, they should reflect the public health in general. Thank you. This was my short introduction. And if you have any questions, I'm open to answer.
Thank you, Rosen. Indeed, we'll follow up on some of the stakeholders that you mentioned in the digital health domain during the. So we'll follow up at the end of the session. And now let me introduce Fredrik Johansson from Chalmers University of Technology, who is one of our collaborators, and I believe that he would talk not only about our collaboration, but also his other successful collaborations within the domain over there in Sweden. Fredrik.
Thank you so much, Dion. Yes, my name is Fredrik, and I work in the topic of AI and healthcare. I'm an assistant professor at Chalmers University, as Dion mentioned, specifically in something called the Data Science and AI division, where almost all of us work with machine learning or AI in some way, and a lot of us work on applications in healthcare. And as you may already know, AI and machine learning is making its way already into the healthcare space through a lot of different types of functions, and some of which we've heard about already in the other talks. For example, in diagnosis, AI systems are used to find problems in X-ray or other kinds of tomography images. AI is used in smart records to improve record keeping for clinicians, so they don't have to spend as much time on it. It's used in monitoring so that we can figure out if a patient needs urgent care, and in decision support to figure out how should we treat a patient in front of us right now. And these are not just interests of mine. It turns out that at Chalmers, the interest in these kinds of questions in health and how we can improve health through various kinds of engineering or technological research that interest spreads across almost all of the department at Chalmers. What I'm showing here is a survey done last year to gauge how many would want to work on health-related topics. And it seems like in almost all departments, 5 to 10% of researchers at this technical university want to work with health or are already working in health-related topics already. I wanted to highlight just 2 initiatives at Chalmers that I'm involved in varying capacity. The first one being the Chalmers AI Research Center, or CHAIR, which is this university-wide center that is supposed to promote and support research internally, but it also has a consortium of external collaborators, including, for example, the local hospital, but also companies like Volvo and others. There's also something called the Health Engineering Area of Advance, where which again is an initiative that spans the university, but here the focus is not only on AI. This is in general, how can we use engineering research or technological research to improve health in some ways. So I mentioned already that one of our more important collaborators within this CHAIR initiative on AI is the local hospital called Sahlgrenska University Hospital. And this is not just one, it's actually a system of 4 different hospitals in the Gothenburg area, which is the second biggest city in Sweden and its extended region. So this system of hospitals have more than 1 million visits from patients per year, which of course generates a lot of data that we could analyze in different ways. And it turns out that this is already being done a lot at the hospital. To no surprise perhaps, that more than 50 AI research projects are already going on at the hospital, some in collaboration with Chalmers and that I'm representing, but some with other collaborators as well. So since there is such a common and large interest between Chalmers and this hospital in these kinds of questions, AI plus health, a steering group was created to try and coordinate research across these 2 institutions. And I'm part of this steering group, and we work to, for example, create joint events, to educate one another, perhaps have dual affiliations and guest professorships and that kind of thing. But more concretely, one of the things that we've worked on so far is to develop a joint research agenda for how we should perform AI plus health research in Gothenburg. And of course, there are many aspects of health and AI research that could be covered by such a thing. For example, on the very extreme end of our side, or the technology side, we have the theoretical analysis of AI systems. How should we understand theoretically what learning systems or statistical systems do? And then we have the other extreme of the health side, where we care about deployment and actually clinical use of the products or the systems that we developed. And in between, there's a whole range of different activities where we can collaborate to make sure that we spend our time wisely. For example, clinicians could impact what theoretical questions we study because we want them to be worthwhile long-term. And in reverse, we could affect clinical deployment by building systems that have theoretical guarantees and so on. So this is the temporal perspective of AI research that connects to health, but we've to try and limit a little bit what we do in collaboration, we've also identified a few focus areas where we think our current and historical activities as these institutions could help sort of the most and to have a largest impact in the shorter term. And these are fairly broad areas like diagnostics and monitoring. Chalmers is very strong in image processing, which is a huge component of AI in health currently. But we also are interested in things like administration and how to run the hospital in the most efficient way. How should we do prognostics to figure out where we need more resources and so on. AI systems and governance refers to things like software engineering and building robust and reliable systems, but also ethical considerations. How should we deploy AI in an ethical way? Dian already mentioned one example of a collaboration that we're doing with GATE, but it turns out that this is also a collaboration with the local hospital. And that one was on Alzheimer's disease. And in particular, we're wondering and we're looking into why it is that some patients who have developed certain indicators of Alzheimer's, why do they progress quicker than others? Why is it that some patients deteriorate much quicker in their cognitive function than other patients who remain much more stable for longer? So this started as a collaboration between Sahlgrenska University Hospital and Chalmers, and here we are looking at, for starters, just data that is collected publicly from other institutions, but we're hoping to move towards something that we can implement clinically at the hospital here in Gothenburg. I won't spend too much time talking about the GATE collaboration because Diane already mentioned it, but there are 2 projects that are going on already together with me and other researchers here in Gothenburg, but also Diane himself and other researchers at GATE. And in one of them, we look at the omics side of this question. How can we identify genetic markers or more complex patterns from genetic information to try and predict who will progress more rapidly in Alzheimer's disease? And in the other project, we're looking at a different aspect, which is if we are supposed to use this system in practice, if we want to predict progression of Alzheimer's disease in a clinical setting, and so we can use these predictions, we want to make use only of data that is available readily in the hospital. We would prefer to use data that's routinely collected. And of course, that means that we can look at what is missing in data currently, what is being recorded in hospitals now, and try to make the best use of that information. I think I'll end here and thank you for your attention. And this was a very brief overview of AI and health research at Chalmers. Thank you so much.
Thank you, Frederick. And I should mention that imputation or the filling in of the missing data is indeed an important task that is to be done with biomedical data, because often there is a substantial amount of data that is missing, and we do not want to discard useful data just because some of it is missing. And last but not least, let me introduce Dr. Todor Kunchev, who is a neurologist at University Hospital Sofia Med, and as the name suggests, it is in Sofia, Bulgaria here. He will talk a little bit about another collaboration that he has with GATE in the field of cognitive diseases. Dr. Kunchev.
Thank you. Just let me share my screen as well. I hope you see my presentation.
Yet. Yes.
Yes. So what I'm going to briefly present the CogniTwin project, a GATE project that we are doing in collaboration with the Faculty of Mathematics and Informatics at Sofia University and with the developers at Rivo Solutions. So the CogniTwin project is a project that I believe will be vital in the management of dementia patient and in the research in this field, especially in Bulgaria. But first, let me just briefly try to emphasize how important dementia has become in the world, especially recently. As we just heard from the keynote speaker, yes, chronic diseases are on the rise, and I believe this is especially true for dementia. And just in the next slide, I will show you why this is such a problem. But first, there are some other factors that make dementia so significant right now. One of them is, of course, the significant change in the way of life of patients with dementia. This devastating progressive cognitive decline, their loss of independence. And on that note, to an almost same degree, this change of life is also valid for their carers. Of course, people with dementia are also a huge financial burden on the public health sector. Dementia is a huge resource consumer in health systems worldwide. And last but not least, moral and ethical issues are also a problem in dementia. And another factor that is important for its significance right now is just that the numbers of dementia patients are rising right now, and this is due to the increased life expectancy. Because as you can see from this chart, increased life expectancy actually leads to increased dementia morbidity and incidence. And this is especially true for the degenerative types of dementia, not so much for the vascular dementia, which is the second most prominent type of dementia. And I believe this slide speaks for itself. As you can see, dementia cases are rising everywhere, but this is especially true for the old continent. And I believe this term is even more true right now. As you can see, until 2050 or 30 years later from now, the dementia patients are expected to rise almost twofold. And now just on why we need to digitalize all this data that we can have from all the cases of dementia patients. Now, first, talking about the national level, we sadly don't have a national register for dementia patients, and this is pretty much a huge problem because a national register really gives a lot of opportunities for better management of the disease and better research. And I believe if the CogniTwin project actually gets on and we play our cards right, I believe the CogniTwin project actually can be a substitute for a national register, or it can actually become the national register of dementia patients. Now, the lack of a national register actually makes it very hard to track patients with dementia, and the responsibility in that case for the management and for the tracking of these patients lies on the shoulders of their carers, and this is not really the optimal version. Another huge problem is that one of the things that can help us in management of these patients is actually cognitive rehabilitation. And this is pretty much practically absent in Bulgaria as well. And I believe in here that the other project that we are working on in collaboration with Rivo Solutions and with the Faculty of Mathematics and Informatics, Cognisoft, I believe this is something that can also help immensely. And of course, when we're talking about dementia research is vital because we need a lot more data. Dementia is one of the aspects of medicine that is still, we are a bit helpless there. So research is vital. And sadly, in Bulgaria, there is dementia research, but it's very small scale. It's usually done by individual doctors, usually working on their PhD thesis, and this should be done in a more large scale. Also, last but not least, again, I believe that this should be done because looking generally at it, I believe it's very easily done. I mean, all these factors, they can be digitalized because they can be quantified and they can be digitalized quite easily. Now, these are just a few slides and I use the opportunity to thank Associate Professor Petrova Antonova because she's the one who made them. This is just a brief overview of the CogniTwin project, the software, and actually in here, I just want to emphasize that we aimed at being quite comprehensive in bringing as much factors as we could, because this, I believe, could be important in the future, and we could make correlations with many aspects of the lives of these patients. So these slides will actually just show the main clusters of factors that we try to collect, and I will just show them briefly one by one. First, we have the anamnestic data that we have from patients, and this is includes the social state of patients, most importantly where they live, in what type of of town or city, and I believe most important if they are alone or they have carers with them. Also their habits, and this includes and not limited to smoking, drinking, sleeping habits, as well as presence of traumas in the past, especially head traumas. Now, the clinical status, this is pretty much the most important aspect, and I will talk about the others in just a few seconds. The test results is the one that I believe will actually be of the most importance, and these include, I believe, everything that is being done right now for the diagnostics of dementia in Bulgaria. First, it's imaging. These are mostly CT and MRI of the head, and the second most important, the neuropsychological assessment and cognitive assessment. These also include tests for anxiety, depression, and so on. Then we have cerebrospinal fluid markers, which is something that is being done in the last maybe 10 to 15 years in Bulgaria, and it's quite vital in dementia research. There's also blood tests, and where this is available, genetic tests. And there is one quite important aspect of factors, and this is the most probable diagnosis. Of course, in here we're just relying on the doctor's main differential diagnosis, because sadly we don't have neuropathology here, which is the one most important factor for determining the diagnosis. But in here we use the how should I say, the most viable diagnosis in each patient, starting with Alzheimer's disease, of course, as this is the most common type of dementia, then vascular dementia, also mixed dementia, and then going to the rarer ones, Lewy body dementia, frontotemporal dementia, Parkinson's dementia, and Parkinson plus syndromes, which are the rarest type of diagnosis in these cases. Then last, we really found it important to include all the types of medication that the patients take, because I believe this is something that should be correlated with everything else that is put in the software. This includes prescription for cognitive disorders, for vascular disorders, also antiplatelet and anticoagulant drugs, where these are needed, neuroleptic and antidepressants, and sleep medication. So this pretty much includes almost everything about what we are doing both diagnostically and therapeutically in people with dementia in Bulgaria. So with that, I would like to thank you for your attention.
Thank you, Dr. Kunchev. This is indeed an interesting and I would say a comprehensive project and a study that you are running there. And we are running out of time. However, I would use the opportunity to eat a little bit from the break and ask you a question or two. To all of our panelists, from your point of view, what is the single most important piece of technology or algorithm or method or methodology that did not exist a few years ago, but is available now and that made the most difference in your line of work? Trying kind of to track the progress before the obvious next question, what happens next, but or maybe I can start, but let's see if anybody else.
Well, maybe from my own point of view, and I believe this is quite different from all the other panelists, I believe it's just the scope that we didn't have before, that that big data that at least for me is new for the last maybe 7 to 8 years, because just like I said in my presentation, of course we all have these doctors that want to do research and they do it, but what usually happened in the last 10 years in Bulgaria, they just get a group of, let's say, 100 patients and they do statistics on that, but we need more. We need that big data and that large scope.
Indeed, for small number of patients, we do not have what is called a statistical power in order to be able to determine informative factors or events. So if anybody would like to, Frederick?
I would just like to chime in there with Turner. I don't think the biggest advancements that have enabled the sort of AI in health progress of recent years, the biggest achievements haven't been in the technological side. The technology has been around for a while. But there's been a lot of work and getting good annotation and good data sets and combining that with existing technology, which admittedly has been advanced. I don't want to take any sort of credit away, but it's a huge number of small pieces that have come together in my mind.
Okay.
And then I will be a little bit more practical. For me, the most important thing is the mindset of the people, because we know that from technology point of view, everything could be done. But the biggest problem now is that most of the people in our sector are not aware of the things that could be done. And this is the main problem, and this is the main bottleneck of all this digital transformation that is not happening, indeed.
Okay, thank you. If I could answer the same question, for me, it is the abundance of easily available computational power, especially with the cloud technologies. Prior to that, one would need an access to a supercomputer. And now, if you need to run heavy computations for a short period of time, you can deploy a lot of relatively cheap resources on the cloud. And the final question, what happens next from your point of view, in your domain? What do you think would be the major innovation or achievements in the next, say, couple of years or 5 years?
Oh, in my point of view, I believe, especially in Bulgaria, because I would speak on the national scale, there is one challenge ahead, and before we reach that progress we're talking about, I believe we need to overstep one specific conservative feature that we have in Bulgarian hospitals, and I believe the hard part is going to be to make as many hospitals as possible to collaborate on these projects. And I'm a bit I'm a bit skeptical about this happening too fast in Bulgaria. So this is something that I worry about.
But given the fact that we are a little bit behind the more developed countries, perhaps some speed up is needed.
Of course, and this is actually the reason why we are behind. So I hope we overcome that faster.
Yes.
I think from my perspective, one of the exciting things about the recent years in the AI development and machine learning development is that things are now moving into application much more than they have previously. But that's also one of the scary things. We are now faced with problems that we never had before, which are related to sort of robust deployment and transfer of systems to domains that they were never applied in. So I think a lot of exciting research will be more on the sort of engineering side and making sure that systems work well in practice. Yeah, I hope that will be taken seriously, basically. Yeah.
Thank you.
And from my perspective, I see that in the very near future, new value chains will be created based on the patient journey. And in this way, all these silos will be broken. And this is quite much supported by the European Union. So I think that in the next couple of years, we will move in that direction.
Okay, thank you. and to follow up on that, the personalized medicine or the patient journey is perhaps what would follow. The equivalent of that, customer insight and customer journey, exists for many years in different industries. And indeed, it seems to be coming into the digital health domain and to the healthcare system. So with that, I would like to thank all of our panelists, also to our keynote speaker, and to apologize to the audience for running a little bit out of time. And I do believe that the next session will start in about 4 or 5 minutes. Thank you, everybody.
Thank you very much.
Thank you so much.
Okay, thank you. Thank you for all of you. It was a very interesting discussion, and thank you for Dr. Kunčev for his time, because I know he's in a COVID section and he has a lot of responsibilities, and we are all with you and supporting you, and thank you for your participation. And I believe that having this digital innovation cluster, so with collecting different stakeholders, will move faster towards next steps and exchange data and do some important things in Bulgaria to be part of the European Union and to follow faster the rest of the Europe. So thank you very much for your participation, and so we'll continue collaborating and working together. And now it's again between panels. We said that we'll have videos presenting different European Center of Excellencies. We'll present AI for CAT, which is in Barcelona. It's a very big also a Center of Excellence, and they will present their work on the mobility, and also they have supercomputer power, so they're very strong. And also other startup company, it's Kelvin company. This is a spin-off, highly ambitious, and they line up with the COVID crisis. And also our students, and they're great with their work, and you'll hear from videos what they're doing. And next session will start in 3:30.
Hi, I'm very pleased to be here and to introduce you I2CAT. I2CAT is the Internet Research Center of Catalonia, based in Barcelona, Spain. I'm Eunice Ribeiro, and I'm the director of the EC, Research and Innovation, Strategy and Policy Department. This department is responsible for the strategies of I2CAT to participate in European projects, putting together researchers, innovators, and a very strong team that we have dedicated to build the digital society of the future. Among all the areas and sectors that we address, both in technology but also in the society of the future, mobility is certainly one of the most important. So today, here, I would like to share with you how much we are doing so far with digital technologies in the mobility area, and how our European projects and our local initiatives are influencing the future that we can expect, and the improvements and the sustainability for mobility in the coming years. So as you see, in I2CAT we face mobility with all our passion. And we like to say that we envision it the same way as the European Commission usually says. So we like the CCAM logo. So the CCAM means cooperative, connected, autonomous mobility. And this is exactly the capabilities and our vision that we want to have it for the future. And what does this mean in practice for our lives as citizens? It means safety on roads. It means green roads. It means more inclusivity for mobility. It means more competitiveness for our European economy. And in I2CAT, we've been participating in several projects that have been contributing in different ways for this vision of mobility, for this combination of connectivity and cooperative systems and automation that enables a whole orchestrated mobility ecosystem for our economy and for our safety. We want to enable user-centric and all-inclusive mobility while improving the road safety, reduce congestion, and promote and reduce very much the CO2 emissions, which are very dangerous for our health and for our future and for the future of our planet. By introducing new mobility services for both passengers and goods, we can make sure that both the citizens and European industry can flourish and harness the future of our society. So in ITOCAT, we've been doing a lot of projects. We've been also collaborating with many different entities because it's a complex ecosystem that engages different value chains and different actors and more different areas. For example, when we think about the connected autonomous vehicles, we have to think that telecommunications will need to be interfaced with the mobility sector. But when we think about electromobility, we also need to think how the intelligent mobility is going to interface and is going to promote the energy transition. And for this reason, working in all these different vectors has been important for us, together with the digital technologies, the role of 5G for improved safety, for improved connectivity, for connecting the whole Europe as one. So in 5G Med, we are working on the interoperability and on the 5G challenges of cross-border corridors in order to tackle the 5G infrastructure that is required to make these kind of enablers to help to happen and to make a sustainable 5G deployment model for the future of mobility that we would like to see replicated all over Europe. So we are working in these different sites. In addition, we are also working with artificial intelligence, promoting the cybersecurity solutions in a particular project named Caramel. We are also part of the 5G Barcelona initiative, an initiative based in our home city, where we want to create open laboratories to test and to develop further 5G solutions. So, thank you very much for all your attention. It's been a pleasure for me to be here and to share with you our experience and our vision for the future and how we are using our technologies and our presence in European projects to promote further our activities. I hope you have enjoyed. If you would like to meet us, feel free to reach us. It's been a pleasure for me to be here. Thank you so much. Bye.
Hello, everybody. It's Greg Kudra from Kelvin Health. Kelvin is a solution for preventive telemedicine, applying AI analysis of thermal images. The problem that we are addressing is that significant amount of people are delaying their medical examinations and do non-preventive medicine measures, which might lead to severe complications or even lethal outcome. This is even more severe in the context that a lot of healthcare providers have no telemedicine or preventive medicine solution or type of care for their patients. Kelvin enables various types of conditions that we can call thermally verifiable conditions to be spotted in the comfort of your home. So how it works, it applies a thermal camera to your mobile phone, where you can take a photo of yourself from a short distance, typically naked above the waist. Then we apply our specific medical thermal segmentation of the image that can spot various types of anomalies and differences, or at least make them visible as part of the thermal image. And as a next step, we apply artificial intelligence analysis of those images using state-of-the-art machine learning approaches to detect various types of anomalies or severe changes in condition. The advantages of those methods in compared to existing medical imaging approaches are numerous. These include the fact that it's a non-invasive solution, it emits no radiation and have no negative impact of your overall health status. It's AI-driven to a huge extent. It can automate the spotting of things that are hard to be spotted by the human eye. And as a result, it enables you also to do in a very inexpensive way daily checks in the comfort of your home. This is directly applicable to various types of conditions. Of course, not every condition has its significant thermal footprint, but there are very important cases like breast cancer in the context of oncology, or autoimmune diseases related to inflammation, various types of skin inflammations in the context of dermatology, traumatology, that can be spotted using our thermal imaging approach. This is also very important in the context of pediatric care, because there it's important not to expose the kids to any invasive or radiation-based methods for monitoring of their condition. Here you can see various examples, for example, fibrosis on the left breast. We have the effect of severe physical activity on the human body. We also can see what is the thermal footprint of various types of traumas and injuries in the emergency response room context. We can have the level of inflammation in the case of RA. We can see various types of vascular conditions like thrombophlebitis, for example. And very interestingly, we can see how in an asymptomatic patient, the thermal approach can still make visible various types of changes in the thermodynamic of their body, which is related to various types of inflammatory processes in the specific patient, even in the context of a single day. We are in the very active R&D phase of the project right now, establishing various types of collaborations with hospitals, both here in Bulgaria, but also leading oncology centers in Italy and Slovenia that are supporting us in the data collection for machine learning, especially in the context of breast cancer. And also, we are about to officially start a collaboration partnership with Novartis Oncology Europe, again, for monitoring of breast cancer conditions using thermal imaging AI, especially in the context of monitoring the effect of therapy of their products in a very non-invasive and no radiation-based approach using Kelvin Health. So our mission is to impact positively the life of many people around the world using our non-invasive solution in the comfort of their home, which might greatly increase the chance of various conditions to be spotted before it's too late. Thank you for your time and attention, and I'm happy to be in contact with you.
Distant constellation to see
I feel like you take me higher. You take me, I feel like you take me. You take me, I feel like you take me. You take me, I feel like you take me. You take me, I feel like you take me. You take me, I feel like you take me. You take me, I feel like you take me. You take me, I feel like you take me. Feel like you take me. You take me, I feel to your heart. September comes and goes away. Memories of celebration. So what has become of us? Remember the promises you made. Second guesses have us fall.
Welcome back to our last panel, which is devoted on the intelligent government topic, which we are working on at GATE Institute, and it will be on disinformation. So it's my pleasure to introduce the moderator of the panel, which is Kalina Boncheva. She is leading the research group on disinformation in GATE Institute, and also she is leading the natural language processing group in University of Sheffield. And she's very well-known researcher in the field. So Kalina, please, the floor is yours.
Thank you for the introduction, Sylvia. It is my real pleasure to be chairing this panel today on disinformation in the Balkans. And we have a wonderful lineup of speakers. So I just wanted to say very briefly why we think that it's really important to study disinformation in the Balkans specifically. The first of all, the citizen susceptibility is among the worst in Europe. Then we are seeing a lot of disinformation, as you will hear from the speakers, which is anti-NATO, anti-EU, pro-Russian, and also some specific ethnic minorities like Roma are also impacted by disinformation. So all of this, in a way, it's different types of disinformation that is being circulating in the Balkans, and I think we'll touch on that as well later in the panel. Until very recently, there was a lack of independent fact checkers in Romania and Bulgaria. You will see that, you will hear the good news that actually this has changed for Romania and is about to change for Bulgaria. So this is really, really good news, and you'll see and hear also about some of the intelligent disinformation analysis tools that are being developed within the We Verify project that it has been kindly funded by the European Commission. However, this project and the tools were funded initially to focus on the sort of Western languages of English, German, French, and it is our next goal through these kinds of alliance of interested researchers and parties to seek ways to further this and get some funding to customize and make this technology available also to researchers in the Balkans to do the research in the local languages and be able to study the local narratives. So without further ado, I would like to introduce Dr. Alberto Ravakin from the European Commission, who will tell us first about the measures that the European Union is taking towards tackling disinformation. Alberto, please, welcome. I think you can share.
Yes. Thank you, Galina. It's a pleasure to be here. Thank you for inviting me. And I think, as you said, it's really important that we all together, support this fight against disinformation. And this is why, since the beginning, the European Commission has started has implemented a strategy that involves that through a multi-stakeholder approach. Let's say it's a strategy that started back in 2017 when we started to have a high-level group on disinformation that informed the Commission through a report about the problem and propose possible solution to this problem. Following that the work done by a high-level group, the Commission issued a communication in April 2018, where for the first time he developed a overarching strategy against disinformation. And since then, we have been working, implementing these strategies. The action plan of December 2018 is basically the following element that focus on the implementation of such a strategy, and recently we have also published the European Democracy Action Plan that basically highlight the future strategy, what we'll do in the next upcoming years. So what are the pillars of this strategy? But certainly there are several pillars. As I said, disinformation is a multifaceted approach that requires a multi-stakeholder participation to deal with the problem. And there is a clear need to involve the online platform to tackle the problem of disinformation, because we all know that although disinformation is not new, it's there since the civilization started. The technologies that are behind the platform, the research engines, the social media, have somehow given the opportunity to malicious actors to implement very sophisticated and successful disinformation campaigns. So the first pillar of our action was to create a dialogue with the platform and to convince them to come up with a code of practice, which they did and was signed in September 2018, to tackle the problem of disinformation. And then within this code of practice, the platform somehow agree to work on specific issue, like the ads that are delivered in web pages that are purveyors of disinformation, transparency of political ads, the use of fake accounts and bots for the amplification of disinformation campaign, the importance of empowering the user in order to recognize disinformation campaign and also to have access to authoritative sources. And last but not least, also the importance of giving researchers and fact checkers access to data so that they can do their job, and so that also society can be more aware of the problem and can develop a better solution to the problem. So this, I would say, so far has been the one of the greatest I would say achievement, although there are a lot of shortcomings, but certainly the code of practice was a premiere in the world. Nobody has developed such a code elsewhere than Europe. The code, in fact, is valid only for Europe. The signatories basically implemented the code only in Europe, although there are other regions of the world that are interested in having the code implemented there. So, as I said, it was a great first achievement, but it's not enough. And we have seen the danger of disinformation during the pandemic and the infodemic related to the pandemic, how dangerous disinformation can be, not only for the democratic process, but also for the health of the citizens. So it's necessary to do something more. We have issued a staff working document in September assessing the code of practice, and we have identified important shortcomings to the implementation, to the code and to the implementation of the code. And then the European Democracy Action Plan that I mentioned at the beginning, it's present a plan in order to improve the code. So the Commission will issue guidance that should help the signatory of the code of practice to improve the code in order to extend the number of signatory, fix some issues related again to the use of fake accounts and bots, to the need to give prominence to authoritative sources, to the need of somehow giving the user the possibility to have access to trustworthy indicators, the need to improve the effort in reducing the financial support through ads that can be displayed on third-party web pages that are purveyors of disinformation, and also to increase the transparency regarding political ads. And last but not least, the need of really implementing a framework that allows researchers to have access to relevant data for doing relevant research on disinformation. We know that there is being for a lot of complaint from the research community that I suppose here is well represented about the lack of data that they have access to that impede to make meaningful research on relevant issue related to this information. So these in broad strokes are the fixes that we are looking for in the next version of the code of practice. And overall, we need also to create a solid framework for monitoring the implementation of the code and the assessment of the impact of the code. So this will be a key action for the future, is to create such a framework for monitoring. So this is one part of our strategy. The other big part of our strategy is the support that we are providing to the research community, to the fact-checking community, in order for the research community to develop tools like the one that We Verified is developing, that other projects in the past have developed. And I want to remind here that we started in 2013 to finance the first project that were looking to how to verify information on the internet. So it's somehow we saw the problem, and the research community saw the problem coming up many years ago, almost a decade ago. This funding has been, I would say, quite generous in the past. We will maybe talk later about the future. But in addition to the funding to the research community, we have another, I would say, big project, which will also take quite some time to be fully implemented, which is the creation of the European Digital Media Observatory. We started with a first call for the creation of the central platform of the observatory, and now this observatory is operational, or has started its operation in June 2020. There is we want this organization, this observatory, to be completely independent from the Commission, although we are funding it. So this observatory has created a board which is completely independent from the Commission and from any public authorities, which will somehow shape up the future of the observatory. And also, the observatory will provide with a technological platform for fact-checking and research, which should support joint fact-checking activity, joint research at the European level. But this is not all, because without real work on the ground, and when I mean work on the ground, I mean I refer to fact-checking, analysis of this information campaign, and exposure of this information campaign to the public, our effort will be meaningless. So that's why we started to finance the creation of 6 national hubs, around 6 national hubs. We have a budget of 9 million for about 6 national hubs. We have closed the call for proposal at the beginning of November, and we are now evaluating the proposal through a panel of independent experts. So when we launch these hubs, I suppose in end of spring 2021 or better summer 2021, we will have an EDMO that will not only have the central platform operational, but will also have national hubs that will start to detect and analyze this information campaign at national level, and they will start to work together in order also to work on common issues, because we very often acknowledge that this information campaign are very similar across Europe and across the world. Similar narrative are let's say tailor-made to the national information ecosystem, but very often they use they have the same structure. So if we broaden knowledge about this information campaign, it's easier to stop them before they create any harm. And so this is in broad stroke what we are doing, and our intention, of course, is not to limit our effort to have only 6 hubs for the observatory, is to have hubs all over Europe. So this is, of course, our long-term goal. We are seeking funding, and I'm pretty sure we will be able to secure funding for the future. So, Kalina, I would stop here, unless you want to hear more. You can, of course, ask me questions, but I think we will have time during the panel to discuss other issues.
Yes, of course. Thank you, Alberto. I would like to just follow up with one question to you at this point in time, because you mentioned about the future. Just in a few, briefly, if you could outline a little bit about how do you think this future will look in terms of going forwards funding in Horizon Europe for this type of work?
Yes, of course, we are starting a new framework program, which is called Horizon Europe. And we are, of course, seeking money to support more research on this information, and in particular, again, on developing tools and systems that support the media ecosystem in fighting the disinformation, support also possibly citizens in fighting disinformation. So I cannot say much because, of course, the program is not yet public. Unfortunately, there is not yet an overall agreement on the budget for the next 7 years. But what I can say is that we are looking also to fund more fundamental research. We have been focusing on innovation in particular in the future, but we realize that we need to do more effort also on fundamental research, because the techniques of those ones that are malicious actor are becoming more and more sophisticated. So we need also to keep up with those, and therefore we will need more basic research, I would say. And as I said before, we are also, and this has been published recently, we intend also to with Digital Europe and with Horizon Europe to finance a media data space. And although the aim of the media data space is to support innovation and creation of new business model in for the digital transformation of the media sector, I believe there will be also business opportunity for those one working on the disinformation phenomenon. So the idea is to have with Digital Europe to launch this infrastructure, to deploy this infrastructure with the help of the industry, and then to have the research project financed through Horizon Europe, developing new tools that they can be integrated later on in this digital infrastructure. So this is again a quick summary of our future ideas, for the futures, and we can discuss this later if needed.
Thank you very much, Alberto. This is perfect introduction to the rest of the panel. And specifically the issue of data access, I think, is difficult for many researchers across Europe, but I think it's particularly difficult also for researchers in the Balkans, because I think the platforms are generally more forthcoming towards collaborations with main Western countries than they are with Eastern European research centers. At least this seems to be kind of my experience. But please allow me to introduce now Professor Nicoleta Corbu from SNSPA in Romania, who will tell us actually about their experience and research in Romania on disinformation. Thank you, Nicoleta. Over to you.
Okay, thank you. I hope you can see my presentation. What I want to do in the few minutes that I am allowed to speak in this panel is to briefly present you the research center that I coordinate at our university, SNSPA, in English, National University of Political Studies and Public Administration in Bucharest, Romania, and then refer to the some of the results that we got in our studies conducted on disinformation effects. And without further ado, let me tell you a few things about our institutional background. So I am the head of the Center for Research in Communication, that is the largest research center in my university. You can see here the labs that are affiliated with this research center. I am the head of the Media Studies Lab, in which we have been conducting for the past 5 years projects related to how the new information environment has changed, especially with a focus on political communication, effects of hate speech in social media, fake news effects related to the new information system, and populist political communication in Europe. This is part of a cost action that has been a huge project that ended recently. And with another research center in my college, actually we are conducting another research on fake news effects, which we were able to change the focus due to the pandemic, and we are actually focusing now on health disinformation related to vaccination. We are now in the pre-testing phase with that. Maybe we'll have time to discuss that later. But now I want to present quickly results of research that we conducted 1.5 years ago that was focused on effects of fake news, because I think there's a lot of talking about how to address fake news, and also addressing them means knowing what kind of effects they might be able to do. 2 years ago, when we started this project, actually, we're very much focused again on political disinformation effects. And just to have a general outlook of that, we are looking for persuasion and virality effects of various kinds of fake news related to the political disinformation, and to what extent these effects are moderated by the level of education and government approval, because we were in political context. This is very much rooted in the Romanian context, and so I am very much in favor of doing comparative research, because you never know if this is very much related to the context of the national background or can be generalized to other countries as well. So what we do, we did a national survey in which we embedded an experimental design. The design looked like this. We basically built a sort of typology of fake news that has 3 main criteria: facticity, high and low, intention to deceive, and valence. Valence was related to what has been called hyper-partisan news, that is a way of framing political issues in a way that is not always false, but can be misleading in various ways. This is just to have a sense of how the stimuli or the treatment in the experiment condition looked like. So they framed the Prime Minister at the time discussing the increase of the economic growth in Romania. So we also had conditions in which we alter the data to make it as a parody or a satire. And just let me show you briefly the main results, of course, with not many details. What is the most important result that we got is that grossly fabricated data has no effect, but rather soft way of manipulating the data in both a negative or positive way could lead to persuasion effects, sometimes with a boomerang effect for negative manipulation. That is, again, I'm referring to the hyper-partisan news. And I think this is particularly important because nowadays, at least in Romania, but I know for a fact that we are not the only country in which this is happening, the very polarized media landscape leave no space for objective, by-the-book journalist routines. So this is the reason why even more that kind of effects might be of interest when thinking of way of debunking information. So the other part of that was related to what the literature calls the third-person effect, which is basically saying that people believe that they are not as much influenced by the media, but others are. In this context, what we wanted to see was to what extent people believe that they might be able to detect fake news, to what extent they believe their close friends or family are able to detect fake news, and to what extent they believe people in general, that is distant others, how we call them, are able to detect fake news. And as you can see, this is just a general overview. We measure that on a scale of 1 to 7. And the results show that people always place themselves above the middle of the scale, their close friends and family on the middle of the scale, and people in general below the middle of the scale. That is, they believe that people can be gullible and they can be duped by the media, by the fake news and the misleading information, but not themselves. This is particularly important because I think it's very important, and Denis is going to definitely talk about that, to have fact-checking tools. But I think because of that kind of third-person effect, which we have been verifying since in 5 different studies, including on adolescents, and it is always confirming that it is there and it is there to stay. So before actually trying to find ways in which to fight this information using fact checkers, we need to make people aware that everybody is actually vulnerable when faced with misleading information. And one particular reason why the people are vulnerable is that because we are always inclined to what is called selective exposure, to actually select that information that confirm our prior beliefs, values, opinions, and so on and so forth. And this is the reason why whenever the misleading information is actually crossing our way, then it means that we can all become vulnerable regardless of what we may think of ourselves and of others. This is just a general overview for people who are interested in looking into what we are actually doing at CNSPA in the research center. And maybe we'll have time later on to discuss more about what we are actually doing now, that is looking into conspiracy theories related to the coronavirus, vaccinations, and stuff like that. Thank you very much.
Thank you very much, Nicoletta. This was really exciting and interesting. And yes, I'm very much looking forward to the discussion in the end, if time allows. So next, I would like to introduce our next speaker, Zlatina Marinova. She's from Stirma AI in Bulgaria, trading as OntoText, and she's the coordinator of the We Verify project. So in her talk, you will see Alberto already mentioned about how similar narratives are circulating around Europe. And you will see how We Verify is trying to address this and how it can build tools to help fact checkers to semi-automatically cross-check whether whether the current narrative they're verifying has already been debunked by a fact checker, for example, in another country. Truly Media is also developing the, We Verify is also developing the Truly Media platform, which Alberto mentioned as well in the context of EDMAR. So without further ado, please allow me to introduce Latina. Thank you.
Thank you, Kalina. Thanks for the introduction. I hope you can see my screen now. Okay. So yeah, you heard that I'm going to present briefly the focus and some of the outcomes of the We Verify project, which is kindly funded by the European Commission as part of the Horizon 2020 program and the specific calls on disinformation. This project is combining the efforts of researchers, verification experts, and technology organizations in providing different methods and tools for helping fighting disinformation. So I'm here representing Sirma Yaik, Trading is Onto Text, which is the coordinator of the project, and we are also a technical partner developing some of the tools for the disinformation fight. So let me start my presentation. Sorry, yeah. So one of the main objectives is to provide tools to journalists and fact checkers that can help them collaboratively tackle the problem of disinformation, and using cross-model tools and methods for helping their work in identifying fake content online. Here we present Truly Media, which actually was an existing tool when the project started, but is currently being further enhanced and developed to integrate results of the project and to enhance its functionalities to help journalists first organize content, first collect content from different sources, being Facebook, Twitter, but also other social media and web pages and so on. Then organizing this content into different disinformation investigations that can be shared between verification experts, and also helping in the verification process by using different tools, some of which are developed within the project to help, for example, analyze a particular image or a particular text that has been shared online to identify whether it is tampered with or it shares some false claims. The other tool that is already actually widely used and is first developed as part of the INVIT project, which is also a European funded project, is the INVIT We Verify verification plugin. You will hear more about this plugin from my colleague Denis Tissot from AFP. So here I will quickly only present some interesting functionalities that were developed as part of the project. One of them is the social network analysis, which allows visual exploration of disinformation networks. In this example, you can see that this is the network created automatically in relation to the hypercapnia claim that was spreading online, so related to the effects of wearing a mask and leading to hypercapnia. This network can be further analyzed by the users to, with the help of our tools, to identify particular communities that help in sharing this information online. The user can zoom in and look into different groups that have been identified as clusters. In this case, some of them are politicians, some are others, and then this can help the verification expert to see who are the main who are the main actors that help in spreading disinformation. Another interesting feature that is developed within the project is the assistant, which is a tool that aims to help both journalists, fact checkers on the one hand, and on the other citizens which are not so familiar with the process of debunking particular claim, but also help them in their attempt to look into the details of, for example, a particular a post they come across in their social media stream. In this example, you can see a Facebook post being analyzed to find out which is the text, what is the image being shared. You can see it down there. And you can already see wording that the content has been flagged. So this is one thing that can tell the user to be careful. The user is then also suggested some potential tools that can help in analyzing this image. For example, the forensic tools that are being created within the project. And on the other hand, we have the integration with a database that we are creating in the project for containing already debunked information, already debunked claims, and known fakes of videos and images. So in this case, the search in this database will actually return a debunk, for example, by full fact, which shows that this picture has been proven to be false. In this database of known fakes, we are further breaking down the information into interesting appearances. So where does this claim originally appear on this Facebook post, and what is the debunking article done by full fact, so the user can follow our links and see the actual debunking article published there. Just quickly to tell you that this database of known fakes also provides a search interface that can help both journalists and fact checkers and researchers to look into its content and see what are debunks related, for example, to COVID or a different topic. And also we provide an overview of the content of the database in terms of what are the sources, the authors, and the languages that we cover in it. This is a very, very brief presentation, but I think this caps my time. So thank you for your attention. If you're interested in following the project, please do so on Twitter. And of course, you can visit our website. Thank you.
Thank you, Zlatina. That was great, really interesting. So as Zlatina mentioned, we have the honor of having AFP as the fact checker here on the panel as well. This is Denis Tessot, and he will tell us some more about the fact-checking operations that they are in the process of setting up in the Balkans. So over to you, Denis. Thank you. Denis, if you're speaking, I don't think.
Yes, sorry. Yes. I'm going to talk about what AFP is doing in terms of fact-checking in the Balkans and about the InVid We Verify plugin quickly. So AFP is one of the top 3 world news agency active in 200 countries. We are the main news agency in Europe because the 2 others are Associated Press in the States and Reuters, who is now British and Canadian. We have a network of more than 2,000 journalists of 80 nationalities, and we are doing now fact-checking in 80 countries around the world. So this is where we are doing fact-checking in the world, mostly within the Facebook journalism project and what is called the Facebook third-party fact-checking network. But we have started also to fact-check with TikTok, for instance. So we are trying to fact-check also with other platforms. So this has been done in only 3 years. We started in 2017 after starting in the French presidential elections in a project called Crosscheck, and it has expanded very, very rapidly. And we are fact-checking in the Balkans for many months now. In the former Yugoslavia, we have this fact-checking blog called Činjenice. And this is an article from yesterday. And there is a specific section on disinformation on Balkans, but also disinformation about Europe and the rest of the world. More recently, we launched also in Romania with another blog called Verificat here, and it is active since a couple of months now. And soon we have in the roadmap also we are going to deploy fact-checking operations in Bulgaria. And of course we are for decades in the region with offices, AFP offices in the Balkan for many years, and reporting about all the events and journalists, I mean media events in any kind of domains like sports, politics and economy and society for many years already. Coming to the InVid We Verify plugin, this verification plugin was launched as was said before during the InVid project, and we are maintaining it and enhancing it with new tools within We Verify. The plugin is a facilitator for AFP for the expansion of AFP in fact-checking, because it allows to quickly master some basic tools for doing verification. And especially we are using the big data of the image reverse search engines to be able to retrieve whether an image or a video has been published in the past. And most of the fake news are in fact images are decontextualized images from the past, which are just put back on social networks, in the platforms. So we are increasing the number of search engines that can be triggered from the plugin. And our last prototype that you can see here, which is already available for fact checkers, and is integrating, for instance, the similarity search to another image search engine, which is the database of non-fakes that was presented just before by Slatina. So it allows also to retrieve whether one particular image has been already involved in a fake situation in another by another debunking operation. The plugin is used now by 39,000 users worldwide in 191 countries. There is no Balkan segmentation on the Google Analytics, but you have on the left side the Eastern Europe, and on the right side the Southern Europe, and you will see that it is already used in several countries, in Romania, in Bulgaria, in Slovakia, in Serbia, Kosovo, Croatia, Albania, etc. And it's increasing over time at a pace of about 100 new installation per day. And thank you for your attention, and get in touch with us if you want more information about it.
Thank you, Denis. This is great, especially because Facebook, for example, is relying on third-party fact checkers like AFP in order to effectively to better moderate and label disinformation on their platform. So it's really encouraging to know that finally there will be such operation for Bulgaria, and also Romania is ongoing, because I think this will help, in fact, reduce significantly, especially the impact of Facebook disinformation on the citizens in the region, hopefully. So next on the panel, we have Todor Galev from an NGO, which is the Center for Study of Democracy. Without further ado, I will allow him to present their work. It's really exciting, specifically looking at foreign disinformation in the region. Over to you, Todor. Thank you.
Thank you, Kalana. Do you hear me?
Yes.
Okay. First of all, I would like to say a few words about my organization. Center for the Study of Democracy is a not-for-profit organization registered in Bulgaria in early 1990s, so just after the collapse of communism. And we have a strong experience since then in EU and internationally funded research and consultancy projects. We work on quite different topics, and one of them is foreign influence and disinformation. And actually, we do have 4 distinct departments. I'm working at the economic department, where the major part of the work on foreign influence and disinformation is done. But actually, this is one of the topics where all the 4 departments of CSD are collaborating on in a multidisciplinary and synchronized fashion. So here are some of the reports and publications that we have done in the on the topic of foreign influence and disinformation. We started with the Kremlin playbook in 2016 when we looked at the Russian economic influence in South and Eastern Europe. Actually, at that time, nobody wants to speak about this, but only few years after that, as you know, I would say this became a very hot topic. In working on foreign influence and specifically on Russian influence in Europe, we came across the topic of propaganda and disinformation. As you can see, our work was quite well recognized and received. Actually, we do have briefings for the US Senate, for the US Commission on Security and Cooperation in Europe, which is a federal commission of the, in the US. We do have briefings for the NATO headquarters in Brussels, for the German Chancellery, for the Foreign Affairs ministries of Germany, France, Austria, and some others, and for many, many different foreign embassies in the region and Europe at whole. And in all of these briefings and our research that we use to produce the results and the conclusions and the recommendations for the briefings, the disinformation topic and propaganda topic was one of the major that people have been interested in. So in terms of Russian influence and disinformation, we found that it dates back to 19th and 2000s. The tools that have been used are state capture instruments, media propaganda and disinformation, and geopolitical pressure. Through the media propaganda disinformation, actually, the foreign governments reinforce the governance deficits in our countries, especially in Southern and Eastern Europe, using combination of economic and political power. What we found is that expansion of Russian direct and indirect support to both Russia-owned and domestic pro-Russian media over the last, I would say, already 10, not 5 years, have been done in 2 ways. Internally in Russia through regulatory mechanism, but abroad, so in Europe in general, through employing the strategy of what is called in literature diffusion proofing, so counterbalancing Western coverage, Western media coverage with the pro-Russian twist. What we found is that there are certain links between disinformation and media ownership or control on media. Disinformation is used as soft power tool of the foreign influence in Europe. Again, there are links between foreign economic footprint and disinformation in Central and Eastern Europe. And this is a bit different than the first bullet about the disinformation and media ownership, because as I'll show you in a while, foreign economic footprint often presents some indirect or hidden links between the disinformation campaigns or propaganda campaigns and economic actors in our countries, and also communication strategies that have been coordinated and obviously controlled centrally by, in this case, Russian government. So one of the examples is here. You can see that the Russian direct economic footprint in the Bulgarian media sector accounts for only about 6 million euro, while the indirect economic footprint, or these are companies that are controlled by the others, account for another 2 million. And in addition, there are a third group of companies that are non-media companies, but are related to the first two groups and controlled by them. And very often, exactly these third type of companies are used for agenda setting in the media through, for example, advertising budgets. So media ownership is only one and less used tools in disinformation and media capture processes in our region. Disinfo campaigns, what we found is that disinfo campaigns engage large community of content creators and providers, starting from RSS aggregator sites, small and medium online news platforms, independent journalists, individual bloggers and opinion makers, and so on and so on. What we found, for example, is that what we called mushroom websites. So small websites are starting to reproduce a given news piece, and then this went to bigger websites, local and regional media, and after 1 or 2 days, it went already into the national media. So we do this in partnership with various stakeholders. I would like just to outline here our partnership with EU Stratcom Task Force. We are doing some fact-checking for them with some of the DGs of the European Commission, but also the Joint Research Center and the United States State Department. As well as, of course, we can't do this without the help and support of and partnership with technological companies. We are proud that we work with some of the companies that have been already mentioned here, like On2Text, ATC, Athens Technology Center, and so on. And here I want just to show you some results from a very recent research, which is still not published actually. This is done in partnership with technological company called Sensica, and we try to monitor the disinformation coverage or the coverage of specific topics and narratives by 4 types of media selected in advance from 8 countries. One media which is owned by Russia formally, one media which is pro-Russian, one media which is a partisan outlet, like in this case, Bulgarian Ataka newspaper. So this is the newspaper of the Bulgarian far-right party Ataka, and one media that we take as a kind of independent normal media. And as you can see from this example here, the trends in this case in the coverage of Crimea-related news by the Russian formally owned media, in this case Newsfront, are quite bigger than for the others. And but interestingly, they follow absolutely the same trends during the time from 2017 to 2019. So it means that pro-Russian media actually what we call twist and duplicate the normal media coverage of certain topics, but with pro-Russian tweets with their narratives that are common for them. Here's another example. It's about the coverage of the topic of Western Balkan EU accession in the context of the Bulgarian EU presidency. And as you can see, because this is not a topic which is of interest of the pro-Russian media, you can see that this is the red, their coverage is much smaller. The same, for example, for Serbian market. When it comes to something which is in interest and part of the pro-Russian narratives, in this case, Kosovo and Crimea, so comparison between the Kosovo and Crimea, which is used by Russian propaganda. The pro-Russian media have much bigger publication activity than the others. And another one which is about Russia and EU, again, it's evident that pro-Russian media are exploiting these narratives much more than the normal media. These are just in short some of the findings and conclusions that we have. Just to mention some narratives that we spot as part of the foreign, I would not say Russian, because in last 2 years we work mostly on foreign, not only Russian, but also Turkish, Chinese disinformation in the region. Related to the EU, and these are actually common narratives that you can find in every one country in the Southeast Europe, and this is very telling. So one of the narratives is about the EU dictate over the EU member states, but also over the accession countries. Another one is EU as a threat to national sovereignty. Another very common narrative is EU as destroyer of traditional values and identities. And here, all the talks about gender and Istanbul Convention and so on and so on. Another is EU as protector, EU's of weak political union, which in comparison to the strong Eurasian Union established by Russia, and so on. So I would finish with this: the similarities that we found in the propaganda and disinformation campaigns across the region are much more than the difference, I would say. Thank you very much.
Thank you, Todor. Okay, so we've got, unfortunately, only like 3 or 4 minutes. I was hoping we'll have a bit more. It's a bit difficult to chair virtually. So anyway, let's try to go through a few questions very quickly. If people can answer just with 1 or 2 sentences, I know that's very hard. So my first question to Alberto actually is, do you think that the community code of practice implementation by the platforms is equally enforced or equally implemented across the countries, for example, across Germany and the UK as compared to the Balkans? Or do you think the Balkans are lagging behind in terms of
it's also an outcome of our assessment, and one of the major shortcoming is the fact that there is no uniformity of implementation of the code across the member states. I don't have now the picture, that detailed pictures member state per member state, but certainly there is no uniformity. So this is one of the issues that we want to solve in the future, and we will certainly ask platform to ensure same treatment for all the member states.
That's great. Thank you very much for the clarification. So next, a joint question to Zlatina and Denis. It's exciting to see all of this new technology in support of verification and fact-checking. Could you say like a couple of sentences each about what do you think will take the effort to adapt the tools to languages in the Balkans?
Well, we are already looking into potential collaborations with local journalists and the local technical organizations to tackle this, researchers also, sorry. So I think that within the We Verify project, we won't be able to pursue this completely because adding more content or processing regional content will be an extra effort. So we'll be looking into other potential sources of funding, be it national or European-wide, to cover this. And of course, we'll be looking into collaborating with everybody interested in this.
Thank you. Denis, do you have something to add?
Sorry. We have observed three main drivers for the growth of the adoption of the plugin, the verification plugin. One is the elections with high stakes. Another one is the recommendation by fact-checking experts. And the other is obviously the localization in new languages. So the plugin is available right now in French, English, and Spanish, and it's France is the first country, Spain is the fifth country. We are using all Latin America in Spanish as well, and USA is the second country now with the recent elections. On top of India, India is the third country. It used to be the second one. So localizing in new languages is key also for adoption, and especially for adoption for more people than experimented fact checkers.
Fantastic, thank you. So I would like to close this panel with one last question towards Nicoletta, which is, I would love if you can say a little bit more about your research on disinformation narratives around COVID in the region. Thank you.
Thank you. I will try to be as brief as possible. So we conducted several surveys this year about the conspiracy theories and things related recently to vaccination. And results show that actually belief in conspiracy theories plays an important part in predicting people's willingness to get vaccinated. And this is the second most important predictor after trust in institutions. Of course, immediately after the pandemic started, we have seen this rally around the flag effect that people trusted more institutions, which is now going on the descendant trend. But leaving aside the trust in institutions, again, belief in conspiracy theories tend to predict to a high degree people's willingness to get vaccinated. That is, the more they trust the narratives related to either vaccination and coronavirus conspiracy theory, the less likely they are to get vaccines. So this has huge implications, but I will stop here. I know we are behind time.
Thank you very much, Nicoletta. So on that note, I'd like to thank all the panelists. And I'd like to say also briefly that the Gate Institute will be organizing a series of webinars where we actually will be going in a lot more depth in all of these topics. And some of our first invited speakers will be those on the panel to actually do an in-depth technical and scientific presentations of their work. So this is not the end of it. This is just the beginning. Please follow us on Twitter and through other social media channels. And we look forward to welcome you again. Thank you very much and have a lovely day. Bye.
Thank you. Bye-bye.
Thank you. Bye.
Thank you very much for your participation. So I would like to thank you all for being part of GATE event today, and my special gratitude to all moderators, keynote speakers, panelists for their interesting insights and inspiring discussions. And by bringing different stakeholders, our partners and collaborators from scientific community, government, business, we showed how big data and artificial intelligence can tackle societal challenges, including COVID crisis, which were covered with almost all panels. And I hope we will enjoy the first Big Data and AI Forum of Gate Institute, and it will lay a foundation for many valuable further collaborations and partnerships. And as Kalina said, it's just the beginning, it's just first year, and a lot more will come. And to have special workshops dedicated to specific topics. We just start discussing now, but there's a lot more to do in the field. And from the whole GATE team, I would like to wish you to enjoy upcoming holidays and stay safe and healthy.